Imagine standing beneath a sky where the very atmosphere itself has become weaponized, where rain does not fall as water, but as molten glass shards that slice through flesh with surgical precision, and where the winds that carry this precipitation reach speeds that would obliterate a commercial aircraft in seconds. This is the reality of HD 189,733b, an exoplanet located approximately 63 light-years from Earth in the constellation Vulpecula, a world so hostile and alien that it defies our conventional understanding of habitability and pushes the boundaries of what we thought planets could become. The discovery of this world shattered our assumptions about planetary climates, forcing astronomers and planetary scientists to confront a scenario that seemed more appropriate for mythology than for actual celestial mechanics. Yet the data collected by the Spitzer Space Telescope and the Hubble Space Telescope confirmed that this nightmare realm genuinely exists in our universe. HD 189,733b orbits so close to its parent star that it completes one full revolution in just 2.2 Earth days, meaning that the planet races around its sun faster than Mercury races around ours, subjecting the entire world to temperatures that reach approximately 1,900 degrees Fahrenheit on its day side, creating an inferno of such intensity that silicon dioxide, the very substance that comprises glass, exists not as a solid but as a vapor in the upper atmosphere. The atmosphere itself, composed primarily of hydrogen and helium with traces of water vapor and methane, circulates in a manner that creates supersonic winds reaching speeds exceeding 4,000 miles per hour, winds that tear across the planetary surface with a violence that renders the concept of shelter meaningless and any notion of stability impossible. As these scorching winds spiral around the planet in a permanent storm system, they carry silicon dioxide molecules upward into the cooler upper atmosphere, where temperatures drop sufficiently for the silicon dioxide to condense and crystallize, transforming from vapor into solid particles of glass that gather in the upper reaches of this alien sky like the most terrifying storm system imaginable. These glass particles, sharp and abrasive, accumulate and eventually fall back downward toward the planet's surface in what scientists have termed glass rain, a precipitation event so fundamentally destructive that it would annihilate anything in its path, slicing through rock and metal with relative ease and rendering any surface exposed to this phenomenon into a pitted and scarred wasteland of erosion and destruction. The persistence of this cycle, year after year and millennium after millennium, stems from the fundamental physics of the system itself, where the extreme proximity to the star ensures relentless heat that maintains the silicon dioxide in vapor form during the day, while the planet's rapid rotation and the resulting atmospheric circulation patterns guarantee that this vapor will be transported to regions where condensation becomes inevitable, creating a self-perpetuating machine of destruction that operates with the indifference of gravity and thermodynamics. We have come to accept HD 189,733b as simply another data point in our expanding catalog of exoplanets, another curiosity in the vast menagerie of worlds orbiting distant stars. Yet the implications remain disturbing and profound, for it demonstrates that nature is capable of engineering scenarios of such hostile intensity that they border on the incomprehensible, and that somewhere in the cosmos, the very substance we use to build windows and observe the universe has transformed into an instrument of obliteration, falling endlessly from an alien sky that offers nothing but suffering to any hypothetical observer who might somehow find themselves standing beneath it. Yet perhaps this is nature's way of reminding us that habitability itself is a luxury confined to the rarest of circumstances, and that the universe's default state is one of profound indifference to the existence of life. Approximately 400 light-years from Earth, orbiting a star in the constellation Pisces, exists a world so hostile to the very concept of life that it stands as perhaps the most viscerally terrifying exoplanet yet discovered by modern astronomy. WASP-76b is a gas giant, similar in many ways to Jupiter, yet it experiences conditions so extreme and so fundamentally alien that even describing them challenges our ability to comprehend planetary environments. The planet orbits its parent star at a distance so close that it completes one full revolution in just over 3 Earth days, and this proximity to its stellar furnace has transformed the world into something resembling a hellscape pulled from humanity's darkest imaginative works. The dayside of WASP-76b, facing its star at all times due to tidal locking, reaches temperatures exceeding 1,700 Kelvin, hot enough to vaporize virtually any compound we might consider solid matter here on Earth. Within the upper atmosphere of this world, hydrogen exists as a plasma, and the very chemical bonds that hold molecules together begin to break apart under the relentless assault of stellar radiation and heat. Yet the most terrifying phenomenon occurs at the precise terminator line, that boundary between the eternal day of the day side and the eternal night of the night side, where something absolutely devastating takes place. Atmospheric scientists and exoplanet researchers have determined that iron oxide compounds, vaporized and superheated on the day side, are carried by powerful winds toward the night side of the planet, where they encounter the dramatically cooler temperatures near the terminator zone. As these iron-laden winds cross from the furnace of day into the relative darkness of night, the iron vapor begins to condense and precipitate. The planet literally rains liquid iron onto its nightside atmosphere, not in gentle drops, but in cascading torrents of molten metal that fall through the clouds like some apocalyptic vision made real. The mechanism driving this phenomenon is rooted in basic planetary physics and chemistry, yet its manifestation is so extreme that it feels almost theatrical in its cruelty. The intense stellar radiation from the host star strips electrons from iron atoms, creating iron plasma on the day side that is carried by atmospheric circulation patterns toward the cooler nightside regions. When these iron ions encounter cooler temperatures at altitude, they recombine into neutral atoms, then bond with oxygen to form iron oxide compounds, which then condense into liquid droplets suspended in the atmosphere. These droplets are substantial enough to represent a genuine precipitation system, not merely atmospheric aerosols, but actual rain composed of one of the densest and most reactive metals found in nature. The human mind struggles to normalize this image because it violates so many of our fundamental expectations about how planetary systems should function. We have evolved understanding rain as water, as life-giving and essential, as something that shapes landscapes through patient erosion and nourishes ecosystems through cyclical circulation. The concept of rain composed of molten iron carries no such associations and serves no function for any conceivable form of life. The winds carrying this iron rain across WASP-76b move at speeds that may exceed the most violent hurricanes ever recorded on Earth, driven by the temperature differential between the day and night sides of the planet. These winds form circulation cells and jets that transport the iron oxide clouds thousands of kilometers across the atmosphere, distributing the iron rain in patterns that shift and evolve constantly. Yet despite the sheer alienness of this phenomenon, despite its complete departure from any weather system we can experience or observe directly, we have incorporated it into our understanding of exoplanet diversity almost routinely. Astronomers document it, publish papers about it, update our models of atmospheric chemistry on ultra-hot gas giants, and continue their observations as if this represents merely another interesting dat. Imagine a world where the surface temperature reaches 2,300 degrees Kelvin, hot enough to melt any known metal, where the very concept of solid ground becomes meaningless because everything exists in a state of perpetual liquefaction. A hellscape of molten rock that stretches across an entire planetary surface with no respite, no cool zones, no refuge from the unrelenting thermal assault that defines existence on 55 Cancri, this exoplanet. Located approximately 40 light-years from Earth in the constellation Cancer, orbits so closely to its parent star that it completes a full revolution in just 18 hours, a proximity so extreme that tidal forces have locked one hemisphere permanently facing the star while the other side exists in eternal darkness. And this proximity combined with the star's intense radiation creates conditions where the entire surface exists as a roiling ocean of liquid lava. A concept almost impossible for human minds to fully grasp, because we have no experiential reference for a world where oceans are not water but molten silicate and iron. The psychological mechanism that makes this difficult to comprehend stems from our fundamental dependence on Earth's water cycle and our understanding of planetary stability. We intuitively understand oceans as vast bodies of liquid water that support life and regulate temperature and create weather patterns. But on 55 Cancri, this entire framework collapses into something far more alien, where instead of cooling evaporation, the surface experiences only deeper heating. Where instead of precipitation bringing relief, there is only the slow, inexorable churning of liquid rock driven by convection currents on an almost unimaginable scale. The reality of this world persists in our cosmological records despite being utterly hostile to any life as we understand it, and we have come to accept its existence as simply another data point in exoplanetary science, catalogued and studied with the same clinical detachment we apply to every other celestial body. Yet the true horror of 55 Cancri lies in recognizing that such conditions are not rare aberrations, but rather common outcomes throughout the universe. That worlds of molten devastation vastly outnumber habitable worlds like ours, and that the safe, water-bearing, temperate planets we consider normal are actually the exceptional cases, the statistical anomalies in a cosmos where burning lava oceans represent the default state of planetary existence. This realization fundamentally shifts our perspective on humanity's place in the universe, transforming Earth from an unremarkable speck into a precious anomaly, a world of improbable fortune where the convergence of distance from our star, planetary mass, and chemical composition created the narrow band of conditions necessary for the emergence of consciousness itself. Making 55 Cancri not merely a distant curiosity, but a mirror reflecting the extraordinary rarity of our own existence. And yet, standing beneath Earth's night sky and contemplating 55 Cancri-E's molten surface, we recognize that this distant hellworld serves a profound purpose in our cosmic understanding. It becomes a celestial reminder that habitability itself is a gift, that the delicate balance permitting life to flourish is not inevitable, but rather the result of countless improbable circumstances aligning in our favor. And that recognition should inspire both humility before the universe's vastness and gratitude for the extraordinary fortune of our planetary home. Perhaps this is why the study of worlds like 55 Cancri matters so profoundly, not merely as abstract scientific curiosities, but as cosmic teachers that illuminate the fragile conditions underlying our own existence, reminding us that life itself emerged not from inevitability, but from a series of fortunate circumstances so improbable that they deserve our deepest wonder and protection. In the constellation of Draco, approximately 790 light-years away from Earth, there exists a world so profoundly dark that it challenges our understanding of what a planet can be. A celestial body designated TRES-2b that reflects less than 1% of the light that strikes its surface, making it darker than coal, darker than the deepest obsidian, darker even than the blackest materials ever created in human laboratories. And this extreme darkness persists not because the planet exists in some distant void untouched by stellar radiation, but rather because it orbits so perilously close to its host star that it experiences temperatures exceeding 1800 degrees Fahrenheit, temperatures so intense that any conventional atmosphere would theoretically become a glowing furnace of ionized gases, yet paradoxically, the planet's composition and atmospheric chemistry have evolved in such a way that instead of reflecting the tremendous heat and light pouring down upon it, the world absorbs virtually all of it, converting that stellar energy into an internal inferno, while appearing to our instruments as little more than a phantom, a void, an absence where a world should be. The mechanism behind this terrifying darkness involves the planet's atmospheric composition, which likely contains exotic compounds that excel at absorbing visible and infrared radiation, while simultaneously being ineffective at reflecting any portion of it back into space. Substances like vanadium oxide and other metallic compounds that exist in states unknown in Earth's laboratories, creating a perfect absorber rather than a reflector, much like how a black hole warps spacetime itself. And this atmospheric condition persists despite the planet being bathed in stellar light, equivalent to thousands of times the radiation Earth receives from the Sun, a logical contradiction that seems to violate our intuitive understanding that brightness should create visibility, that heat should create luminosity. What makes TRES-2b particularly unsettling to contemplate is that despite our advanced astronomical instruments and spectroscopic analysis, we struggle to fully comprehend how something so actively tortured by stellar bombardment remains so utterly invisible to direct observation. How a world experiencing such extreme conditions has apparently stabilized into this state of absolute darkness, and we have normalized this impossibility simply through classification and naming. Reducing a phenomenon that should provoke existential dread into a mere catalog entry in our expanding database of exoplanets. A simple designation that strips away the profound strangeness of a world that absorbs the fury of a star while reflecting darkness back into the cosmos. Yet in this darkness lies a strange beauty. TRES-2b represents not a failure of nature, but rather a demonstration of how matter and energy can organize themselves in ways that transcend our terrestrial expectations, reminding us that the universe is far more inventive in its physics than our limited experience on Earth would suggest. and perhaps what we perceive as an absence of light is merely the presence of a process we have yet to fully understand. Perhaps one day, when we develop telescopes powerful enough to peer directly at TRES-2b's surface, we will discover that this darkest of all known worlds holds secrets about planetary formation and atmospheric chemistry that will fundamentally reshape our theories, revealing that darkness itself, the absence of reflection, is merely another language through which the cosmos speaks its infinite complexity. Until then, TRES-2b remains a humbling monument to the limits of human perception, a world that exists in defiance of our categories, orbiting its star in absolute silence and absolute darkness, asking us the most fundamental question: how much of the universe remains invisible not because it is distant or small, but because it simply refuses to shine? Imagine a world so close to its parent star that it completes an entire orbit in less than 6 hours, a celestial proximity so extreme that the same side of the planet perpetually faces the sun in a synchronized dance of gravitational locks, meaning that one hemisphere experiences an eternal, unrelenting day while the other dwells in absolute, unchanging darkness, and this is the reality of Kepler-70b. A ultra-hot Jupiter discovered in 2014 by the Kepler Space Telescope orbiting a star located approximately 2,000 light-years from Earth in the direction of the constellation Cygnus. The surface temperature on the day side reaches approximately 4,200 Kelvin, which translates to roughly 3,927 degrees Celsius, a temperature so extreme that it approaches the melting point of iron and far exceeds anything that could sustain even the most extremophile organisms known to science. And at these temperatures, the entire atmosphere would exist in a state of perpetual boiling, with clouds of vaporized minerals and metals rising from the surface in supersonic winds that exceed 5,000 kilometers per hour, creating a hellish maelstrom of superheated plasma where no solid matter could persist in its normal state. The psychological mechanism that makes Kepler-70b particularly terrifying resides in our ability to comprehend proximity and heat through lived experience. For we understand what it means to be burned, what it means to feel pain from excessive temperature, and we can extrapolate from these basic sensations what it would mean to exist on a world where the ground itself is hot enough to melt lead, where the atmosphere is a crushing, toxic soup of vaporized rock and metal, where the gravitational tidal forces constantly reshape the planet's interior, generating massive internal heat that adds to the already unbearable surface conditions. What persists despite logical analysis is a kind of existential dread that such places actually exist in our universe, that somewhere beyond our protective atmosphere, in the cold vacuum of space, planets are enduring conditions so far removed from anything in human experience that they challenge our sense of what reality permits, and we have come to accept this knowledge as simply another fact about our cosmos. Normalizing the existence of hellworlds that would seem like pure fiction if we encountered them only in mythology rather than through careful astronomical observation. Yet perhaps this normalization itself reveals something profound about human consciousness, our capacity to absorb the extraordinary into the ordinary, to read about a world where the very concept of a stable surface becomes meaningless, and then simply turn the page, carrying forward the quiet knowledge that reality contains infinities of suffering we will never witness and could never prevent. This acceptance of cosmic horror as mere data point perhaps represents our species' greatest adaptive strength, the ability to contemplate the uncontemplatable without fracturing under the weight of it, and in that quiet acknowledgement lies both a measure of our resilience and a subtle surrender to the indifference of a universe that permits such infernos to burn, unwatched and unmourned, across the gulfs of space. And yet in this surrender lies a peculiar freedom, for if we can accept that Kepler-70b burns in solitude, we might also recognize that our own fragile world, with its temperate zones and life-sustaining oceans, represents not merely a planet but an improbable sanctuary, a pocket of gentleness carved from a universe of extremes, and this knowledge, rather than diminishing our sense of wonder, only deepens it. In this light, Kepler-70b ceases to be merely a data point about planetary physics and becomes instead a mirror reflecting back to us the preciousness of our own existence, reminding us that worlds like ours, with breathable air, liquid water, and conditions amenable to the emergence of consciousness, represent the rarest of cosmic jewels, and perhaps this is why the study of such hellworlds matters, not to deter. Approximately 470 light-years from Earth, in the constellation Auriga, orbits one of the most horrifying planetary systems yet discovered by modern astronomy, a world designated WASP-b that is slowly being torn apart and consumed by its parent star in a process so gradual and inevitable that it resembles nothing so much as a cosmic predator methodically devouring its prey over the course of millions of years. This hot Jupiter, a gas giant roughly 1.5 times the mass of Jupiter itself, orbits so perilously close to its host star that it completes a full revolution around the star in just over one day, a proximity so extreme that the stellar radiation heats the planet's upper atmosphere to temperatures exceeding 8,000 Kelvin, hot enough that atoms themselves are stripped from the planet's gaseous envelope in a continuous stream of material flowing away into the void. What makes WASP-b uniquely terrifying is not merely its proximity to its star or even the scorching temperatures it endures, but rather the undeniable fact that the star is actively pulling the planet apart through gravitational forces, elongating it into a teardrop shape, and the planet is losing its atmosphere at a rate of approximately 10 billion kilograms per second, a hemorrhaging of matter so tremendous that material forms a vast, elongated tail stretching behind the planet as it orbits, a tail that extends millions of kilometers into space like the tail of some cosmic comet eternally fleeing from an inescapable doom. The mechanism behind this destruction operates through the complex interplay of tidal forces, where the immense gravitational pull of the star stretches the planet in the direction of the star while simultaneously pulling away at it, combined with the relentless heating that provides the thermal energy necessary to accelerate particles to escape velocity, creating a feedback loop in which the planet loses mass, becomes less dense, becomes more susceptible to further atmospheric loss, and spirals inexorably toward its eventual complete annihilation in the heart of its parent star. Observations suggest that WASP-12b will likely be completely consumed within approximately 10 million years, a timescale that is simultaneously enormous to human perception yet vanishingly brief in astronomical terms, meaning that somewhere in the universe right now, a world is being methodically devoured, atom by atom, layer by layer, with no possibility of escape or intervention. And yet this process, this slow cosmic cannibalism, occurs without drama or spectacle, proceeding with the same indifferent inevitability as all the other forces that shape the universe, continuing regardless of whether anyone observes it or considers it terrifying. Yet in this cosmic tragedy lies a profound scientific gift. The study of WASP-b and systems like it has fundamentally transformed our understanding of planetary formation and migration, revealing that worlds need not remain in stable, circular orbits, but can drift inward toward their stars in a process that may explain the existence of hot Jupiters throughout the galaxy, suggesting that the very destruction unfolding around WASP-b represents a common evolutionary pathway for gas giants across the universe. Furthermore, the discovery of WASP-12b's doomed trajectory serves as a stark reminder that planetary systems are not static monuments to cosmic stability, but rather dynamic arenas where worlds are born, migrate, transform, and ultimately perish. A humbling perspective that situates our own relatively serene solar system not as the inevitable norm, but as one fortunate outcome among countless others unfolding across a universe far more violent and volatile than our ancestors could have imagined. When we contemplate WASP-12b's fate, we are forced to reckon with the possibility that countless other worlds throughout the cosmos may be undergoing similar fates beyond our detection, their deaths unwitnessed and unmourned, reminders that the universe operates according to physical laws that are utterly indifferent to the existence or persistence of the worlds. Imagine a world where every surface, every crevice, every imaginable space is consumed by water in its most violent and relentless state, where the very atmosphere itself has become a suffocating soup of steam and moisture so dense that it blocks out any possibility of seeing more than a few meters in any direction, and where the temperature at the surface hovers around 430 degrees Fahrenheit, hot enough to boil water instantaneously, yet the water never stops flowing, never stops churning, never stops existing in this perpetual state of turbulent transformation. This is GJ1214b, an exoplanet located approximately 47 light-years from Earth in the constellation Lepus, a world that represents one of the most alien and utterly hostile environments ever discovered in our cosmic neighborhood. The planet is classified as a super-Earth or mini-Neptune, occupying that strange middle ground between terrestrial worlds and gas giants, with a mass approximately 6 times that of our own planet and a radius nearly 2.7 times larger, making it a bulbous, swollen sphere wrapped entirely in water. beneath which lies a mantle of compressed ice so dense that it exists in exotic crystalline forms that cannot exist on Earth. What makes GJ-1214b so particularly terrifying to contemplate is not merely the existence of water in such abundance. For we understand water, we drink it daily, we float upon it, we have built our entire existence around its presence, but rather the complete transformation of water into something wholly unrecognizable and utterly hostile to any form of life as we comprehend it. The planet orbits its parent star, a red dwarf considerably smaller and dimmer than our Sun, yet it completes one full orbit in merely 1.5 days, pulling it into an extremely tight, claustrophobic dance around its stellar master, and this proximity to its star bathes the world in tremendous heat that penetrates even through the thick clouds of steam and vapor that eternally shroud its surface. The water on GJ-1214b exists in a state of permanent convulsion, with massive thermals rising from the superheated depths, creating towering columns of steam that ascend kilometers into the atmosphere before cooling, condensing, and falling again as torrential rain that immediately vaporizes upon contact with the blistering surface, creating a cycle so intense and so continuous that it defies the gentle, life-sustaining water cycles we observe on Earth. There is something profoundly unsettling about conceiving of a world where the fundamental properties of a substance we take for granted have become so distorted by extreme conditions that it transforms into an instrument of complete environmental hostility, where water, the universal solvent, the molecule that makes life possible, becomes instead a weapon of absolute desolation and an environment that erases any possibility of complexity or diversity or the emergence of anything remotely resembling consciousness. Yet it is precisely in such extreme environments that we are forced to confront the boundaries of habitability itself, to question whether life might exist in forms so radically different from our own that we would scarcely recognize it as living, and to recognize that the universe is far more vast and terrible and wondrous than our terrestrial experience could ever prepare us to imagine. Perhaps in the depths of GJ-1214b's superheated oceans, beneath pressures that would crush terrestrial creatures to atoms, exotic chemistries might unfold in ways we have yet to imagine, chemistries that operate on principles as foreign to our biochemistry as silicon-based life or organisms that derive energy from radiation itself, reminding us that the universe's creativity far exceeds the narrow parameters we have drawn around the concept of life. And as we gaze upon worlds like GJ-1214b through our telescopes and instruments, we are reminded that habitability itself may be far more expansive a concept than our limited terrestrial perspective has allowed us to conceive, and that the search for life in the cosmos demands not mere. Imagine a world where the very atmosphere itself has become a weapon of unimaginable violence, where storms do not merely rage across a planetary surface, but instead move with such deliberate ferocity and organization that they seem almost conscious in their destructive intent. HAT P7b, a gas giant located approximately 1,200 light-years from Earth in the constellation Cygnus Flower, presents precisely this scenario on a scale that defies human comprehension. This exoplanet, roughly the size of Jupiter but significantly closer to its parent star than Mercury is to our Sun, experiences atmospheric conditions so extreme that the very concept of weather as we understand it becomes almost quaint by comparison. The planet's dayside experiences temperatures reaching approximately 2,800 Kelvin, hot enough to vaporize almost any known substance, while the night side plummets to temperatures that would render even the coldest regions of our own solar system balmy and hospitable. What makes HAT P7b particularly terrifying, however, is not merely these temperature extremes, but rather the storms that manifest within this hellish atmosphere, storms composed not of water vapor or nitrogen, but of vaporized minerals and elements that condense into sapphire and ruby crystals as they rise through the atmospheric layers. These crystalline formations, driven by winds that exceed 7,000 kilometers per hour, create perpetual tempests of gemstone shards that circle the planet in great bands and vortices, each particle of corundum razor-sharp and suspended in superheated air that would instantly incinerate any conventional spacecraft that attempted to penetrate it. The mechanism by which these storms persist and intensify involves the fundamental interaction between the planet's extreme heat differential and its rapid rotation, which creates wind shear of truly apocalyptic proportions, allowing the storms to organize and sustain themselves indefinitely rather than dissipating as terrestrial storms eventually must do. What is perhaps most profoundly unsettling about HAT P7b's Sapphire storms is that they represent a kind of atmospheric perfection for their conditions, a system that has achieved such complete optimization to its environment that the storms do not merely survive but thrive, persisting across centuries and millennia without any apparent dissipation or weakening. And in this way, they serve as a reminder that catastrophe and terror are not aberrations in the cosmos, but rather inevitable expressions of physics and chemistry when circumstances align in particular configurations, and that somewhere across the vast expanse of space exist worlds where the very concept of stability and safety have no meaning whatsoever. The sapphire storms of HAT P7b may persist for timescales that dwarf the entire history of human civilization, grinding and reshaping the planet's upper atmosphere into an ever-evolving sculpture of crystalline violence. In this sense, HAT P7b does not merely experience weather, it exists as weather, a world consumed entirely by its own atmospheric fury, indifferent to observation, untouched by any possibility of mitigation or understanding. Yet should humanity ever develop the technological capacity to observe HAT P7b's atmosphere in unprecedented detail, we would likely discover that even within this maelstrom of crystalline destruction, certain patterns emerge, hierarchies of storm systems, perhaps even regions where the violence achieves a kind of terrible balance, suggesting that even in the most seemingly chaotic environments, the universe imposes an underlying order that we have yet the sophistication to perceive. Perhaps the most humbling aspect of studying HAT P7b is recognizing that such worlds demand we abandon our terrestrial intuitions entirely, that the storms circling this distant gas giant operate according to principles of atmospheric dynamics so alien to our experience that they effectively constitute an entirely different category of planetary phenomenon, one that challenges us to expand our conception of what weather itself can encompass. In the constellation Leo, approximately 36 light-years from Earth, orbits one of the most paradoxical celestial bodies ever discovered by human astronomy, a world that defies the fundamental principles we believed governed planetary physics and the behavior of matter itself, a place where ice burns with the intensity of a raging inferno while remaining impossibly solid, where temperatures reach nearly 1,000 degrees Fahrenheit, yet the planetary surface maintains a crystalline frozen structure that should not, by any rational understanding of thermodynamics, be able to exist in such conditions. Gliese 436b is a super Neptune, a world roughly 20 times the mass of Earth yet significantly smaller than our own Jupiter, orbiting so close to its parent star that it completes one full revolution in merely 2.5 Earth days, trapped in a gravitational embrace so tight and suffocating that the star appears to occupy nearly 3 times the size of our Sun in its sky. The extraordinary phenomenon that defines this world and renders it uniquely terrifying is the existence of what scientists call hot ice, an exotic state of water that forms only under extreme pressure and temperature combinations that would seem mutually exclusive, contradictory, impossible, a substance that researchers have actually created in laboratories, but which persists in our universe only in the most hostile and unforgiving cosmic environments. The mechanism that allows this nightmare scenario to unfold is rooted in the properties of water molecules under compression far beyond anything we encounter naturally on Earth, where the intense gravitational pressure from Gliese 436b's substantial mass creates layers of water so densely packed that the molecular structure becomes fundamentally transformed, creating crystalline formations that remain solid and rigid even as the infrared radiation from the nearby star bombards the surface with temperatures that should instantly vaporize conventional ice into steam. What troubles the human imagination is not merely the logical contradiction of burning ice, but rather the existential weight of knowing that physics permits such perversions of reality, that the universe contains environments so alien and hostile that they violate our deepest intuitions about how matter should behave, that somewhere among the stars exists a world where water, that most essential element for life as we understand it, becomes something utterly foreign and hostile, transformed into a substance that is simultaneously frozen and tormented, rigid and burning, a material that embodies the worst possible combination of states. And yet this hellish world may possess an ocean beneath its burning ice crust, a vast hidden sea of liquid water where, impossibly, conditions might approach the chemistry necessary for exotic forms of life to emerge, suggesting that even in the universe's most contradictory and hostile realms, the potential for existence persists in ways that continue to challenge our understanding of what worlds can sustain and what life might ultimately require. Such discoveries remind us that the universe's most inhospitable worlds may harbor secrets we have yet to comprehend, that the very conditions we instinctively associate with sterility and death might instead represent laboratories for chemistry and phenomena entirely beyond our current scientific frameworks, demanding that we perpetually expand our conception of where life's possibilities might emerge across the cosmos. The methane that might accumulate in Gliese 436b's atmosphere, released from its burning ice crust by stellar radiation, could drive chemical reactions that produce organic compounds, the building blocks of life itself, in an environment that seems designed by nature to destroy rather than create, yet paradoxically offers the raw materials for biochemistry we have scarcely begun to imagine. The paradox of Gliese 436b thus stands as a humbling reminder that our chemical intuitions, forged in Earth's benign environment, may represent merely the narrowest slice of what the universe permits, and that life itself might f. Deep within the constellation Virgo, approximately 2,000 light-years from Earth, there exists a planetary system that defies nearly every condition necessary for life as we understand it, orbiting what is known as a millisecond pulsar designated PSRB 1257+12, and this particular world, PSRB 1257+12b, represents perhaps one of the most hostile environments imaginable for any form of biological existence. The pulsar itself is a neutron star, the collapsed remnant of a massive star that exploded in a supernova event billions of years ago, compressed so densely that a teaspoon of its material would weigh as much as all the mountains on Earth combined. And as this incomprehensibly dense object rotates at extraordinary speeds, completing hundreds of revolutions every single second, it generates beams of electromagnetic radiation that sweep across space like the searchlight of some cosmic lighthouse. Except these beams carry energy levels that would instantly vaporize any ordinary matter unfortunate enough to stand in their path. The planet PSRB 1257+12b orbits this maelstrom of radiation at a distance that might seem safe by interplanetary standards. Yet safety is merely a relative concept in this system, because the radiation bath that constantly washes across this world is so intense and so relentless that the very concept of a stable atmosphere becomes impossible. And any surface that might exist would be continuously scoured and stripped away by the particles and waves of lethal energy that the pulsar ceaselessly broadcasts outward. The mechanism that makes this environment so fundamentally incompatible with life operates on the principle of electromagnetic radiation intensity, where the closer proximity to the pulsar combined with the extreme energy output of the rotating neutron star creates conditions where atoms themselves are ionized and torn apart, where chemical bonds cannot form because any moment of stability is immediately disrupted by the next wave of radiation, and where the very building blocks of matter are in a constant state of violent agitation that prevents the formation of molecules, compounds, or anything remotely resembling a stable structure. What persists in our consideration of such worlds is a curious duality in human thought, for while we intellectually understand that such places are utterly uninhabitable and have always been so since their formation in the violent aftermath of stellar collapse, we continue to study them and contemplate them as though they hold some hidden mystery or unexplored potential. And this persistence of curiosity, despite absolute logical certainty, speaks to something fundamental in human nature. A refusal to accept complete and utter impossibility, a stubborn insistence on wondering what might be even when every particle of scientific evidence declares that nothing could ever survive in such a place. And so we have normalized the existence of these radiation hells as part of our expanding catalog of planetary nightmares, treating them not as places of unthinkable destruction, but as points of data in our increasingly comprehensive map of the cosmos. Yet in this very act of cataloging cosmic horror, we discover something unexpected. That understanding these lethal worlds clarifies by stark contrast what conditions life actually requires, transforming PSRB 1257+12b from a mere curiosity into a profound teacher of planetary physics, and a sobering reminder that the universe's indifference to biological existence is not malevolence, but simply the default state of almost everything that exists beyond our small, protected sphere. In this way, PSRB 1257+12b becomes not merely a warning of what to avoid, but rather a baseline measurement against which we can evaluate the genuine miracle of Earth's delicate magnetic fields, stable atmosphere, and distance from stellar catastrophe. circumstances so improbably favorable that their rarity across the cosmos underscores just how extraordinary our own existence truly is. In the constellation Lyra, approximately 620 light-years from Earth, there exists a world so profoundly hostile to any conceivable form of life that its very existence challenges our fundamental understanding of planetary formation and stellar dynamics. Kelt 9b represents a category of exoplanet known as an ultra-hot Jupiter, but the designation fails to capture the sheer extremity of conditions on this world. The surface temperature of Kelt 9b reaches approximately 4,320 Kelvin, which translates to roughly 3,947 degrees Celsius, making it not merely one of the hottest known planets in our galaxy, but fundamentally hotter than many of the stars that surround it, hotter even than our own sun's photosphere, hotter than the burning surface of stellar bodies that have ignited nuclear fusion in their cores. The planet orbits so perilously close to its parent star, Kelt 9, that it completes one entire orbit in merely 1.3 days, meaning that a year on this world passes faster than a single human week on Earth, and the tidal forces have long since locked one hemisphere perpetually toward the star while the other faces eternal darkness. What makes Kelt 9b particularly terrifying from a conceptual standpoint is not simply the abstract nature of these temperatures, but rather the inescapable realization that planets can exist in such extreme configurations at all, that the orbital mechanics and gravitational dynamics of the universe allow for worlds to drift inward from their distant formation zones into the roasting embrace of their host stars, progressively hotter with each passing century. The physics that permits this planetary migration is entirely sound and predictable, explained through well-understood mechanisms of gravitational interaction and disk dynamics. Yet somehow we have come to accept that such worlds exist without fully confronting the implications of their existence. We have normalized the idea of planets burning away in stellar radiation, of worlds where the atmospheric pressure alone would liquefy any substance we consider solid at room temperature, of places where the very concept of a surface becomes meaningless because rock itself behaves as a fluid under such extraordinary heat and pressure. We discuss Kelt 9b with the same clinical detachment we apply to studying our own world, cataloging its properties and marveling at its extremity, as though we were merely observing an interesting laboratory experiment rather than encountering a vision of cosmic violence playing out across hundreds of light-years of space. A relentless process of stellar consumption that continues even now, even as you read these words, with Kelt 9b slowly spiraling inward toward its inevitable destruction. Within a few million years, Kelt 9b will be consumed entirely by its star, its atoms scattered into the stellar wind as though the planet had never existed at all. And yet in this moment, in this astronomical instant before its annihilation, it stands as a monument to the universe's indifference to the concept of habitability, a world that exists not despite being hellish, but perhaps because such extremity is merely one of infinite configurations that stellar systems can assume. Yet perhaps this is the universe's true lesson, that in the vast cosmos, the conditions we regard as prerequisites for life, moderate temperatures, stable orbits, chemical stability, are not universal requirements but rather the exception, local anomalies in a cosmos where Kelt 9b's Inferno represents a far more common destiny for worlds that dare to form too close to their stars. In this context, Kelt 9b ceases to be merely an astronomical curiosity and becomes instead a sobering reminder that our own Earth, with its clement skies and life-sustaining temperatures, owes its habitability not to any universal principle but to a precise gravitational accident, a fortunate positioning in a stellar system where such fortune is extraordinarily rare. Imagine standing on the surface of a world where the very concept of weather has been twisted into something so fundamentally alien that our language struggles to describe it, where rain does not fall as water but as superheated vapor composed of vaporized stone and mineral compounds, where the atmosphere itself is literally made of the planet's own crust, suspended in a state of perpetual transformation. Ko-Ro-T-b is an ultradense terrestrial exoplanet orbiting its parent star so closely that it completes an entire revolution in just 16 hours, positioning it in an orbital configuration where one hemisphere faces the star in permanent daylight while the other side exists in an eternal twilight, creating a temperature differential so extreme that the day side reaches approximately 2,200 Kelvin. Hot enough to vaporize rock and mineral compounds into a gaseous state. On this scorched face of the planet, the surface temperature soars beyond what we would consider the melting point of most rock formations transforming the ground itself into a state somewhere between solid matter and gas, where minerals and stone are literally being sublimated directly into the atmosphere above. The atmosphere that surrounds this hellish world is not composed of nitrogen and oxygen, or even the hydrogen and helium of gas giants, but rather a dense soup of vaporized silicates and other mineral compounds that have been torn from the planet's crust by the intense stellar radiation, creating clouds of rock vapor that circulate in the extreme winds generated by the temperature gradient between the perpetual day and the eternal night. What makes Co-Rho-T7b truly terrifying is that this rock vapor, superheated and dense, begins to precipitate as the air moves toward the night side of the planet where temperatures drop below the condensation point, meaning that rain literally falls across this world composed not of water, but of molten and semi-solid droplets of stone and mineral material. A meteorological process that we might observe in a foundry or an industrial facility, but which plays out continuously across an entire planetary surface. The psychological disturbance inherent in contemplating such a world stems from the fundamental violation of our understanding of what constitutes weather and rainfall, concepts that have been intrinsically linked to water in the human experience since our species' first evolved consciousness. Yet here exists a celestial body where the same meteorological processes operate with entirely different material, demonstrating that the universe's mechanisms care nothing for our categorical distinctions or our comfort with familiar natural phenomena. We have normalized our understanding of exoplanet discovery through the framework of potential habitability and the search for Earth-like conditions, yet Co-Rho-T-B reminds us that the universe operates at scales and intensities that render our normalizing frameworks almost uselessly quaint, a place where geological processes occur on timescales measured in hours rather than millennia, where the distinction between weather and geological catastrophe becomes meaningless, and where the very substance that composes a planet's foundation becomes the medium through which it tears itself apart. In the shadow zones where day meets night, vast cyclonic systems of vaporized basalt and feldspar swirl in perpetual motion, their circulation patterns driven by temperature differentials that would dwarf Earth's most violent hurricanes, yet composed entirely of materials we associate with permanence and stillness. Co-Rho-T-B thus becomes not merely a world of impossible weather, but a demonstration that the very atoms comprising planetary crust can be conscripted into atmospheric cycles, that nothing, no matter how seemingly fundamental to a world's structure, remains immune to the transformative power of stellar proximity and gravitational imprisonment. The iron-rich minerals that precipitate in these rock rains would accumulate across the twilight zones in vast dunes of metallic dust, creating landscapes that shimmer with the oxidized remains of a W. In the constellation Cygnus, approximately 400 light-years from our solar system, orbits a planet that represents perhaps the most unsettling mirror humanity could imagine to its own world, a celestial body designated Kepler-442b that exists as Earth's sinister doppelganger, sharing uncanny similarities in size and mass while possessing conditions so fundamentally hostile to life that it seems to mock the very possibility of habitability itself. Kepler-442b circles its parent star in a death-defying orbital path of merely 8.5 hours, completing a full revolution around its sun in less time than it takes most humans to complete a full night's sleep, moving at velocities so extreme that the gravitational forces would stretch and compress any object caught in its embrace. The surface temperature of this world reaches approximately 2,000 degrees Fahrenheit, hot enough not merely to vaporize water, but to transform it into superheated plasma that dances in the atmosphere like the breath of an ancient furnace, a temperature sustained by the planet's intimate proximity to its star, which looms in the sky with proportions so enormous that it would dwarf anything humanity has ever witnessed. The psychological mechanism that makes Kepler-442b so profoundly disturbing rests in the realization that it possesses almost identical mass and radius to Earth itself, suggesting that in some alternate cosmic circumstance, our own world might have developed along entirely different trajectories, might have been drawn into dangerous stellar orbits, might have been subjected to tidal forces that would have shattered continents and boiled away atmospheres in antiquity. Scientists theorize that Kepler-442b was likely formed much farther from its parent star in a cooler region of the protoplanetary disk, but was subsequently dragged inward through gravitational interactions, perhaps destabilized by the presence of other planets or stellar perturbations. forced into an ever-tightening spiral toward its doom in a process that revealed how precarious planetary positions truly are, and how easily the conditions necessary for life can be fundamentally undermined by the invisible mechanical forces governing celestial mechanics. What renders this world truly nightmarish is the recognition that despite the extreme conditions and the apparent certainty that no biological organism could possibly endure such an environment, the planet continues to exist in a state of slow orbital decay, gradually falling toward its star with a mathematical certainty that ensures its eventual annihilation, representing not merely a failed world but a world in active self-destruction. Caught in an inexorable death spiral that illustrates the temporary nature of all planetary bodies. The realization that persists despite our rational understanding of stellar dynamics is that Kepler-78b exists as a prophetic warning, a tangible example of what awaits all worlds eventually, a testament to the finite lifespan of planets themselves, and this knowledge somehow integrates itself into our collective consciousness as an uncomfortable acknowledgement that even worlds, even the sanctuaries of entire ecosystems and civilizations, are not permanent, not guaranteed. Not protected by any fundamental cosmic law from destruction and decay. Perhaps this is why Kepler-78b captivates astronomers and philosophers alike. It forces us to confront not merely the alien nature of distant worlds, but the uncomfortable truth that our own Earth, despite its apparent stability and the illusion of permanence we have constructed across millennia of civilization, operates within the same physical laws that govern the destruction of this infernal twin. Subject to the same cosmic forces that will eventually claim all celestial bodies in the vast thermodynamic unraveling of the universe itself. In contemplating Kepler-78b's inexorable descent toward oblivion, we recognize that Earth's own distant future may follow similar trajectories as our sun expands into a red giant, transforming our world from cradle of life into a charred monument of what once was. Imagine a world in orbital chains so extreme that it experiences the most violent temperature fluctuations of any known exoplanet, swinging between scorching inferno and merely deadly heat in a matter of hours, a phenomenon so thermally brutal that it defies our conventional understanding of planetary stability. HD 80606b orbits so close to its star during certain points in its highly eccentric elliptical path that the surface experiences flash heating of such intensity that temperatures can rise by over 1,000 degrees Kelvin in less than a few hours, transforming the planet from a world of approximately 400 Kelvin to nearly 2,000 Kelvin as it races through its perihelion passage. The mechanism behind this terrifying oscillation lies in the planet's unusually elongated orbit, where it travels at vastly different distances from its parent star, sometimes positioned where it receives crushing stellar radiation and other times driven back to a distance where some cooling can theoretically occur, creating a thermal cycle so extreme that any atmosphere would be stripped away, and any solid surface would experience perpetual structural stress from the constant expansion and contraction. The psychological weight of contemplating such a world emerges from our deep intuition about stability and equilibrium, for we live on a planet where temperature changes occur gradually enough for life to adapt. Yet HD 80606b reminds us that the universe contains no such mercy, no such guarantee of temperate progression. What persists most troubling about this reality is how casually it exists in our cosmos, how this world continues its violent thermal dance year after year, millennium after millennium, with no awareness of the horror such conditions would represent to any form of life, and how our own stable planetary home begins to feel not like the norm, but rather like an improbable statistical miracle. A rare pocket of consistency in a universe fundamentally designed around extremes that would annihilate everything we understand as viable existence. Yet even in this cosmic horror lies a strange invitation to humility, to recognize that our existence depends not on universal laws favoring habitability, but on the fortuitous arrangement of circumstances that allowed our particular corner of space to remain, improbably and temporarily, survivable. This recognition carries practical weight as well. It drives our search for biosignatures on worlds with more moderate conditions, while simultaneously expanding our definition of habitable to include the possibility that life, in forms we cannot yet imagine, might exploit even these extremes through mechanisms of dormancy, rapid repair, or thermophilic adaptation that would seem impossible by our current understanding. The study of HD 80606 WASP-79b thus becomes not merely an exercise in cataloging planetary oddities, but a crucial laboratory for understanding the boundaries of chemistry and physics itself, a place where we might discover whether the periodic table of elements behaves differently under such extreme thermal stress, and whether matter itself retains properties we consider fundamental when subjected to such violent oscillations. Early observations of HD 80606b's atmospheric response during these thermal spikes have already revealed unexpected resilience. Spectroscopic data suggesting that certain molecular bonds reform with surprising efficiency during cooling phases, hinting that chemistry itself might possess adaptive pathways we've never considered. Pathways that could fundamentally reshape our assumptions about which worlds remain forever sterile, and which might harbor life in forms as alien as the worlds they inhabit. If such molecular resilience proves commonplace across extreme exoplanets, we may need to fundamentally revise our models of chemical evolution, recognizing that the crucible of violent thermal cycling might not destroy complexity, but rather forge it, suggesting that life's emergence could be less dependent on stable conditions than on the sheer creative pressure of surviving impossible extremes, a possibility that transforms HD 8060. Consider the atmosphere of Venus, a planet so chemically hostile that it transforms the very concept of weather into something that belongs in humanity's collective nightmares rather than in our solar system. For suspended within those clouds that obscure the surface completely are droplets of sulfuric acid so concentrated and corrosive that they would dissolve organic matter with an efficiency that makes our strongest industrial solvents seem almost quaint by comparison. The clouds of Venus are not water clouds like those that drift across Earth's skies, bringing rain and nourishment to life below, but rather towering formations of sulfuric acid that stretch across the entire planet in thick bands, creating a perpetual haze that has never once parted to reveal the surface beneath. And these clouds move with a velocity so extreme that they circle the entire planet in just 96 Earth hours, generating wind speeds that exceed 300 kilometers per hour in the upper atmosphere, creating a phenomenon that scientists call superrotation, which means the clouds move far faster than the planet itself rotates on its axis. What makes this scenario particularly terrifying is not merely the presence of acid clouds, but the realization that this atmosphere is maintained through a feedback loop of extraordinary complexity that involves sulfur dioxide, water vapor, and sulfuric acid, engaging in a chemistry so elaborate and self-sustaining that the clouds have persisted for billions of years without fundamental change, continuously recycling their own components in a closed system that has no equivalent in our experience. The psychological mechanism by which we process this information involves a strange disconnect between intellectual understanding and visceral comprehension, for we can read the data about Venus's atmosphere and appreciate the numbers abstractly, yet we struggle to truly internalize what it means to exist in a place where every breath would sear your lungs with acid before you could even complete a single inhalation, where the clouds are so thick that if you stood on the surface, you would exist in perpetual darkness despite the planet being closer to the sun than Earth, and where the pressure at ground level is 90 times greater than Earth's atmospheric pressure at sea level, creating a composite nightmare of heat, pressure, chemical warfare, and complete sensory deprivation, all occurring simultaneously. Perhaps most disturbingly, we have normalized this planetary hellscape through our scientific discourse, referring to Venus almost matter-of-factly as a failed terrestrial planet or as a cautionary tale about runaway greenhouse effects, thereby transforming one of the most objectively horrifying environments in our solar system into merely a data point in our conversations about planetary science. A reduction that allows us to sleep at night, despite the fact that such a place actually exists mere astronomical distances away. A continuous reminder that nature is capable of creating conditions so fundamentally inimical to life and consciousness that our attempts to contextualize or rationalize them seem almost absurdly inadequate in the face of such raw, persistent, chemical hostility. Yet even this normalization fails to diminish the fundamental strangeness of standing at the edge of our solar system's most acidic precipice and recognizing that beneath those rolling clouds lies a world that was once, billions of years ago, potentially habitable. A planet that possessed oceans and temperate conditions before some catastrophic shift in atmospheric chemistry transformed it into the acid-shrouded tomb it remains today, suggesting that Venus is not merely a hellscape of alien hostility, but rather a monument to the fragility of planetary habitability and the terrifying speed with which life-supporting worlds can transform into their precise opposites. This transformation serves as a sobering reminder that Earth's own atmospheric chemistry, though currently stable, remains perpetually vulnerable to the same cascading feedbacks that consumed Venus, a vulnerability that should inspire not awe. Deep within the constellation Puppis, orbiting a star located approximately 850 light-years from Earth, exists a world so fundamentally hostile to conventional planetary science that its mere existence challenges everything we believed we understood about atmospheric composition and planetary stability. A massive exoplanet designated WASP-121b that orbits so perilously close to its parent star that it completes one full revolution in merely 1.27 days, which means that if you were standing on this world, you would witness sunrise and sunset with a frequency that would render human circadian rhythms completely meaningless. What makes WASP-121 be particularly terrifying to contemplate is not merely its orbital proximity to its star, but rather the extraordinary composition of its atmosphere, which scientists have determined contains vaporized metals, a phenomenon so extreme that it represents a category of planetary atmosphere that most astronomers did not seriously consider could actually exist in practice, though the theoretical frameworks had existed for decades. The atmospheric conditions on WASP-121b are so intensely hot that conventional elements which on Earth remain solid or liquid at nearly all conceivable temperatures instead exist in gaseous states, with temperatures reaching approximately 2500 Kelvin in the upper atmosphere, a heat level so extreme that iron, silicon, and other metallic compounds simply cease to behave according to our everyday understanding of how matter organizes itself. The gravitational forces acting upon WASP-121b create pressure differentials that would instantly obliterate any human structure, and the stellar radiation bombarding this world constantly strips away atmospheric layers at a rate that would seem to suggest the planet should have lost its entire atmosphere billions of years ago, yet somehow material continues to exist in this hellish state. What persists most troubling about WASP-121b is that we have normalized the discovery of such worlds despite the fact that their existence forces us to fundamentally reconsider what planets can be, how they can behave, and what physical laws govern their development. Treating these metal atmosphere exoplanets as merely interesting data points, rather than confronting the philosophical implications that the universe is far stranger and more hostile than our evolutionary history ever prepared us to imagine. Yet perhaps this is precisely the point, that our universe contains not merely variations on familiar themes, but entire categories of worlds that operate under principles so alien to our experience that they serve as reminders of the vast gulf between what we have evolved to comprehend and what actually exists in the cosmos, a humbling recognition that should inspire not fear, but rather a profound sense of wonder at the sheer diversity of planetary states waiting to be discovered. As we continue to map these ultra-hot Jupiters and their impossible atmospheres, each discovery becomes a mirror reflecting back our own limitations, reminding us that the universe's true nature reveals itself only to those willing to abandon their preconceptions and embrace the extraordinary as merely another chapter in the ongoing story of cosmic diversity. WASP-121b itself may eventually evaporate entirely, its atmosphere stripped away by relentless stellar winds until nothing remains but a barren core, a fate that transforms this metal atmosphere world into a temporal paradox, a planet that represents both the apex of planetary extremity and a preview of its own inevitable obliteration. A celestial object that teaches us that even the most exotic worlds are not permanent fixtures, but rather fleeting expressions of cosmic processes operating across incomprehensible timescales. In this context, WASP-121b becomes not merely a curiosity of atmospheric chemistry, but rather a profound meditation on impermanence itself, a world whose vaporized metals and impossible conditions represent a fleeting moment in the eternal dance of stellar evolution, where even the most extreme planetary states. Consider the atmospheric conditions that exist within the depths of Jupiter, a gas giant so massive that it could contain more than 1,000 Earths within its volume, where the pressure at certain depths reaches levels that fundamentally challenge our understanding of what matter can endure. At the cloud tops where we typically observe Jupiter from our telescopes and spacecraft, the pressure is roughly equivalent to Earth's atmospheric pressure at sea level, a deceptively gentle beginning to a descent into one of the solar system's most hostile environments. However, as one travels deeper into Jupiter's atmosphere, the pressure increases exponentially, doubling every several kilometers of descent, creating a gradient so severe that it fundamentally transforms the behavior of gases and elements in ways that terrestrial physics can barely accommodate. At depths where pressures reach hundreds of thousands of times greater than Earth's surface pressure, hydrogen gas itself begins to behave in extraordinary ways, transitioning into states of matter that exist nowhere else in our solar system, compressed so intensely that its electrons are stripped away and its atomic structure is fundamentally altered. The deeper one descends, the stranger and more violent the conditions become, until at the theoretical core where pressures may exceed 100 million times Earth's atmospheric pressure, the very concept of traditional matter becomes meaningless, replaced by states of degenerate matter that physicists struggle to fully comprehend or model with confidence. What makes this phenomenon psychologically terrifying is not merely the abstract knowledge of extreme pressure, but the contemplation of the absolute impossibility of survival for any known form of life or even most material substances. The realization that any human, any spacecraft, any probe would be crushed not gradually, but almost instantaneously, compressed into an unrecognizable form of matter before consciousness could even register the experience. The human mind struggles to genuinely comprehend pressures of such magnitude because our evolutionary experience has never required us to understand forces beyond what our bodies encounter in everyday life, giving us no intuitive framework for imagining what it means to be compressed by the weight of an atmosphere trillions of times heavier than our own. Yet despite this incomprehensibility, humanity has normalized Jupiter's crushing pressure as simply another planetary feature, another educational fact to be filed away in textbooks and planetarium presentations, another curiosity about the solar system rather than a genuinely alien and fundamentally hostile phenomenon that defies human survival in every conceivable way. A casual acceptance of something that would destroy us so completely that the very atoms composing our bodies would be forcibly reorganized into entirely different configurations. And yet beneath this normalization lies a profound dissonance. We can describe Jupiter's pressure with mathematical precision. We can calculate that a human body would be compressed to the size of a marble, and still fail to truly grasp what such annihilation means, for our language and imagination were forged in the gentle pressures of Earth's surface, forever limiting our ability to emotionally apprehend the absolute violence occurring in the depths of a world so fundamentally unlike our own. This gap between intellectual understanding and emotional comprehension becomes especially acute when we consider that Jupiter's pressure doesn't merely crush. It fundamentally reorganizes matter at the atomic level, transforming hydrogen into exotic states like metallic hydrogen that possess properties we can barely predict. A transformation so complete that it represents not destruction, but transfiguration into something utterly alien to our terrestrial experience. And in this profound transfiguration lies perhaps the deepest source of our unease. Jupiter's pressure doesn't merely destroy worlds, it reveals the contingency of all matter, the fragile specificity of the conditions that allow anything recognize. Imagine a world where one side of the planet faces its star in a permanent, unrelenting embrace, where the surface temperature climbs to nearly 2,000 degrees Fahrenheit, hot enough to melt lead, hot enough to vaporize water instantly upon contact, creating a landscape of molten rock that flows like an ocean across the entire hemisphere, locked in eternal daylight. Kepler-10b, discovered in 2010 and orbiting a star only 11 million kilometers away, represents one of the smallest exoplanets we have ever confirmed, a rocky world roughly 1.4 times the size of Earth. And yet it exists in a state of such extreme thermal violence that our minds struggle to fully comprehend the physics at play. This is a tidally locked planet, meaning one face perpetually burns while the other remains locked in absolute darkness. A world so close to its parent star that the gravitational forces have long ago stopped any rotation, fixing its position in space like a prisoner chained to a furnace. The dayside glows with an infernal intensity that would be visible from space as a beacon of pure thermal radiation, while the night side plunges into temperatures that barely reach the freezing point of water, creating the most extreme temperature differential imaginable across a planetary surface. The atmospheric conditions, if such a thing can even be called an atmosphere on this hellish world, would consist of vaporized rock and exotic gases created by the intense heating on the dayside, gases that might flow across the Terminator line in patterns we struggle to model with our current understanding of planetary physics. What makes Kepler-10b particularly unsettling to consider is not merely its extreme conditions, but rather the fact that such a world should not exist according to our earlier models of planetary formation and migration. We theorized that planets this close to their stars could not form where they currently reside, that they must have migrated inward over millions of years, shedding their primordial atmospheres and water in the process, until only a barren, lifeless rock remained, orbiting in a gravitational death spiral that will eventually lead to its destruction as the star's outer layers expand during its red giant phase. Yet Kepler-10b persists, and its existence forced us to reconsider everything we thought we understood about how planetary systems could develop and evolve. The psychological mechanism at work when we contemplate this world is one of primal recognition, a deep awareness that here exists a place where the fundamental forces of physics have been cranked to their maximum intensity, where the gentle processes that allow life to flourish on Earth have been inverted into agents of absolute annihilation. We understand intellectually that the extreme heat on Kepler-10b's dayside would tear apart any molecular bonds instantly, that no conceivable chemistry could survive even for microseconds in such conditions. Yet we continue to discover these ultra-close orbiting planets with increasing regularity, finding them throughout the galaxy in numbers that suggest this configuration might be far more common than our early models predicted. What persists despite having no logical reason for us to be disturbed by it is perhaps the recognition that this world, while utterly hostile to any form of life as we understand it, exists in a state that our universe permits and in fact seems to favor according to the statistics we continue to gather. We have normalized the existence of such worlds, incorporated them into our understanding of cosmic diversity, and yet the image of a planet literally cooking itself alive on one hemisphere while freezing on the other continues to exert a subtle psychological pressure on our consciousness. A reminder that the cosmos contains not only wonders, but horrors beyond human experience. Worlds where the very concept of habitability becomes meaningless in the face of physical realities that operate at scales and intensities that make Earth seem like the gentlest place imaginable. Imagine a world that has been systematically dismantled, stripped down to its absolute foundation, with nearly everything that once comprised its existence torn away by the relentless forces of stellar proximity and gravitational torment. This is the reality of TOI 849b, a planetary remnant orbiting a star located approximately 250 light-years from Earth in the constellation Scorpius, a world so fundamentally violated by cosmic circumstance that it challenges our very understanding of what a planet can become when subjected to the most extreme conditions the universe can impose upon it. TOI 849b was once, in all probability, a gas giant similar to Jupiter, a massive sphere of hydrogen and helium that contained perhaps 10 times the mass of our own home planet. Yet something catastrophic occurred in this distant system, something so violent and persistent that it fundamentally transformed the nature of this world into something barely recognizable. Over millions of years, the intense radiation and gravitational forces from its host star began drawing away the planet's atmospheric envelope, stripping away layer after layer of gas like a sculptor removing material from marble, until what remained was the exposed iron core, a dense, naked remnant of planetary destruction rotating in the harsh glare of unforgiving stellar radiation. This process, known as atmospheric stripping or erosion, occurs when a planetary body orbits close enough to its star that the stellar wind and extreme heat overcome the gravitational hold keeping gases bound to the world, causing those gases to evaporate and escape into space, leaving behind only the solid, metallic core that once lay safely hidden beneath thousands of kilometers of atmospheric protection. The psychological mechanism that makes this concept so profoundly unsettling stems from our implicit understanding that atmospheres represent protection, that they are shields against the void, and to imagine a world stripped of this essential layer feels like witnessing a violation of something fundamental and sacred. Yet TOI 849b persists in this exposed state, orbiting just 3 million kilometers from its star, completing an orbit every 18 hours in a slow dance of continuing destruction. The surface of this exposed core likely reaches temperatures exceeding 2000 Kelvin, hot enough to vaporize any remaining volatile compounds and render the world a hellscape of molten metal and elemental fury, yet it endures as a testament to the cosmos's capacity for transformation, a monument to the violent processes that reshape worlds across the universe and remind us that planetary existence, no matter how seemingly permanent, remains fundamentally impermanent in the face of stellar forces. What makes TOI 849b particularly valuable to astronomers is that it represents a visible window into planetary evolution, allowing us to observe the final stages of a process that may have claimed countless worlds throughout the galaxy, and to contemplate whether Earth itself might face a similarly catastrophic fate in the distant future when our own sun begins its inevitable expansion into a red giant. Yet in contemplating such distant futures, we find ourselves drawn to the sobering recognition that TOI 849b is not merely a curiosity of astronomical interest, but rather a mirror reflecting back to us the finite nature of planetary systems themselves, a cosmic memento mori that whispers of transformation and impermanence written across the very fabric of existence. In this way, TOI 849b becomes not merely an object of study, but a profound teacher, a celestial body that invites us to reconsider our assumptions about permanence and asks whether the greatest tragedy of existence lies not in destruction itself, but in the indifference of the universe to the worlds it unmakes. Perhaps it is this very indifference that grants TOI 849b its strange nobility, not as a victim of cosmic violence, but as a silent witness to the universe's relentless mathematics, orbiting on through the darkness with the dignity of something that has endured the unendurable. In the constellation Centaurus, approximately 92 light-years from Earth, orbits a planetary body that defies nearly every convention we have come to expect from worlds within stellar systems. A massive gas giant designated HD 106906b that exists in a state of profound and seemingly permanent isolation, cast out into the cold darkness at a distance so vast that it might as well inhabit a separate realm entirely from its parent star. This world, with a mass somewhere between 9 and 13 times that of Jupiter, travels in an orbit so elongated and so distant that it takes approximately 540,000 Earth years to complete a single full revolution around its host star, a duration so incomprehensibly lengthy that the entire recorded history of human civilization represents merely a negligible fraction of a single orbital year. The star itself, HD 106906, is a young stellar system no more than roughly 13 million years old, which means that this exoplanet has spent essentially its entire existence traveling through the void in near solitude, separated from any meaningful gravitational influence or warmth. The mechanism that created this remarkable exile appears rooted in the violent dynamical processes that shaped the system during its earliest formation, a period when multiple planetary embryos collided, merged, and gravitationally ejected one another in a cosmic game of billiards that left this particular world cast outward to the periphery, separated from the family of stellar radiation and companionship that characterizes most planetary systems we observe. Scientists believe that this world likely formed much closer to its star through conventional planetary accretion processes, but subsequent interactions with other massive bodies, or perhaps an undiscovered stellar companion, sent it careening outward into the freezing darkness, where it now drifts in almost complete isolation, receiving virtually no heat from its distant sun, existing in conditions so cold that the surface temperature hovers near absolute zero. A place where no conventional form of life could possibly survive, a place of such complete and utter desolation that it represents perhaps the ultimate expression of planetary abandonment in our known universe. And yet we have normalized this cosmic loneliness, accepted it as simply another chapter in the diverse catalog of planetary formations, treating this profound isolation as merely an interesting quirk, rather than a reminder of how precarious and chaotic the very forces that shape worlds truly are. Yet perhaps there is a strange dignity in this exile, a testament to the raw forces that sculpt the cosmos, that even in its abandonment, HD 106906b endures, a solitary witness to the universe's indifference, orbiting faithfully through the void as if still tethered by invisible threads to a home it can scarcely remember. And in studying this forsaken world, we glimpse a humbling truth about our own cosmic circumstance, that planetary systems are not the orderly, harmonious arrangements our early telescopes suggested, but rather the survivors of ancient catastrophes, each world a product of gravitational violence and chance encounters that might have scattered it into the darkness just as easily as they allowed it to remain. In this light, HD 106906 b becomes not merely a curiosity, but a mirror held up to the fragility of planetary existence itself, reminding us that worlds like our own Earth represent fortunate survivors of a cosmos far more violent and unpredictable than the stable orbits we observe today might suggest. The isolation of this distant exile ultimately teaches us that the universe's default state is not order but chaos, and that any world blessed with proximity to its star, with companions in its sky, with the possibility of life, has won an improbable lottery against astronomical odds. In this sense, HD 106906b stands as a cosmic memento mori, a distant reminder that our own planetary system's stability is neither inevitable nor permanent, and that the gravitational waltz continues still, reshaping worlds across the galaxy in ways we consider the astronomical anomaly designated WASP-79b, a gas giant exoplanet orbiting a star located approximately 900 light-years from Earth in the constellation Scorpius, a world so physically impossible in its very existence that it seems to violate the fundamental principles we believed governed planetary formation across the universe. This massive world, comparable in mass to only half of Jupiter, yet possessing a radius nearly twice that of Jupiter itself, represents one of the most extraordinarily inflated gas giants ever discovered by human observers, a planet so impossibly expanded and puffed outward that its overall density becomes almost absurdly low, lower in fact than the density of water, meaning that if one could somehow place this enormous world into an impossibly massive cosmic ocean, it would simply float to the surface like a massive balloon. The mechanism behind this terrifying inflation stems from the planet's extraordinarily close proximity to its host star, a distance so intimate that WASP-79b completes a full orbital revolution in merely 3.5 days, subjecting the atmosphere to intense stellar radiation and gravitational heating that causes the upper layers of gas to expand outward dramatically, pushing against the planet's gravitational pull with such force that the world balloons into this grotesquely oversized form. The surface temperatures on this inflated giant reach approximately 1,000 degrees Celsius, hot enough to vaporize any solid material and drive atmospheric expansion at velocities that would shred conventional matter apart. Yet the planet persists in this state, continuously buffeted by stellar winds and radiation, its bloated form a testament to the extreme conditions that can exist in orbital systems far removed from our own solar system's comfortable stability. What makes WASP-79b particularly unsettling is not merely its physical impossibility within our previous models of planetary physics, but rather the realization that this world represents not an exception, but rather part of an entire category of exoplanets known as hot Jupiters, massive gas giants orbiting so close to their parent stars that they undergo this horrifying inflation, and somehow humanity continues forward with its observations and calculations, cataloging these disturbing worlds as though their existence were utterly unremarkable, despite the fact that such planets challenge everything we once thought we understood about how worlds form, grow, and stabilize in distant systems. Yet perhaps this very challenge to our understanding represents the greatest gift these inflated giants offer, a humbling reminder that the universe's diversity far exceeds the boundaries of our theoretical frameworks, and that worlds like WASP-79b, in all their grotesque impossibility, continue to reshape our comprehension of planetary science with each new observation and measurement we obtain from the distant depths of space. As astronomers continue to refine their understanding of these anomalous worlds through missions like the James Webb Space Telescope, each new observation of WASP-79b and its kindred hot Jupiters provides crucial data that forces planetary formation theory to evolve and adapt, suggesting that the mechanisms by which worlds assemble themselves across the cosmos operate according to principles far more nuanced and complex than our earlier models could have anticipated. The discovery of migration mechanisms, whereby massive planets spiral inward from their formation zones in cooler outer regions toward their stars, has provided a compelling explanation for how such gravitationally dominant worlds come to orbit so perilously close to their host stars, transforming our understanding of planetary system evolution from static models to dynamic processes of constant orbital reshaping and celestial rearrangement. These migration events, once thought to occur only under extraordinary circumstances, now appear to represent a common and perhaps inevitable stage in the formation histories of planetary systems throughout the galaxy, suggesting that worlds like WASP-79b Ulti, deep within the constellation Virgo, approximately 57 light-years from Earth, orbits a celestial body so fundamentally alien in its composition and characteristics that it challenges our very understanding of what a planetary body should be. A world designated GJ504b that exists in a state of perpetual thermal violence that makes even the most extreme environments within our own solar system appear hospitable by comparison. This exoplanet, discovered in 2013 through infrared imaging techniques, represents a category of astronomical objects known as young hot Jupiters, massive gas giants that orbit perilously close to their parent stars in configurations that conventional planetary formation theory suggests should be impossible. Yet there it remains, defying our expectations with an almost deliberate obstinacy. What renders GJ504b particularly terrifying to contemplate is not merely its extreme temperature or its unusual orbit, but rather the specific quality of its appearance, for this world glows with a distinctly pink hue in the infrared spectrum, a coloration that betrays an atmosphere so turbulent and superheated that it radiates visible light despite the immense distance from which we observe it, suggesting a world locked in an endless state of thermal upheaval and atmospheric convulsion. The surface temperatures of GJ504b exceed approximately 11,000 Kelvin, making it hotter than the photosphere of our Sun, a heat so intense that any conventional notion of planetary geology becomes meaningless, for at such temperatures, the very concept of solid matter dissolves into theoretical abstraction. The psychological impact of contemplating such a world stems from a fundamental disconnect between our intuitive understanding of planetary existence and the reality that GJ504b presents, because our minds evolved to comprehend worlds like Earth, places with solid ground and weather patterns and day and night cycles. Yet GJ504b offers none of these anchors to our understanding. Instead, it exists as a kind of cosmic furnace, a ball of roiling atmosphere and exotic chemistry that orbits its star in merely 5.5 days, completing a full revolution faster than Mercury does in our own solar system, creating a temporal disorientation when we attempt to imagine what existence on or near such a world would entail. This pink nightmare persists in our astronomical catalogs and in our collective consciousness because it represents a category of discovery that fundamentally expanded our comprehension of possible worlds, forcing us to acknowledge that the universe does not operate according to the parameters we had assumed, and that vast populations of planets may exist in configurations and states that bear no resemblance whatsoever to the orderly architecture we find here within our cosmic neighborhood. The discovery of GJ504b and its companions has subsequently revealed that planetary systems organized around massive young stars frequently produce these hot Jupiter configurations, suggesting that worlds fundamentally hostile to any conceivable form of life may represent a common rather than exceptional outcome in cosmic evolution. A sobering realization that reframes our own planetary system's relative tranquility as perhaps a fortunate anomaly rather than a universal standard. Yet perhaps this realization carries its own strange comfort, for in contemplating worlds so utterly hostile to terrestrial life, we gain a deeper appreciation for the delicate balance of conditions that permitted consciousness itself to emerge on our small blue world, a consciousness now capable of perceiving and understanding these distant pink nightmares across the vast gulf of interstellar space. In this sense, GJ504b serves as a cosmic mirror, reflecting back to us not the horrors of an alien world, but rather the profound improbability of our own existence, and the extraordinary privilege of inhabiting a planet where the delicate interplay of distance, mass, and stellar radiation has conspired to create the conditions necessary for life, thought, and the very capacity to wonder at such distance. Upsilon Andromedae b orbits a star approximately 44 light-years from Earth, and it represents one of the most extreme environments known to exist within our observable universe, a world so hostile to any conceivable form of existence that it seems to exist almost as a theoretical punishment for matter itself. This gas giant, discovered in 1996 and confirmed through decades of astronomical observation, completes one full orbit around its parent star in merely 3.6 days, which means it races through its planetary cycle at a speed that would make the fastest objects in our solar system appear almost stationary by comparison. The gravitational forces acting upon this world are so monumentally powerful that the planet itself is tidally locked to its star, meaning one hemisphere faces the burning radiation and heat of its parent sun, while the other exists in permanent, absolute darkness, creating not merely night and day, but two fundamentally different physical realities existing on the same planetary body. The dayside temperature reaches approximately 1500 Kelvin, a heat so intense that it would instantly vaporize any form of water, any organic chemistry, any known molecular structure that we associate with life, rendering the surface into a roiling landscape of superheated gases and plasma-like conditions that make the interior of the Sun seem almost hospitable by comparison. Yet this extreme is matched by an equally incomprehensible opposite on the night side, where temperatures plunge to levels of such profound coldness that the atmosphere itself would begin to condense and precipitate, creating storms of exotic frozen compounds that would fall like rain in the perpetual darkness, accumulating in vast oceans of substances that no human civilization has ever encountered in their natural state. The atmospheric composition itself contains winds that travel at speeds exceeding 7 kilometers per second, driven by the temperature differential between the scorched dayside and the frozen nightside, creating a perpetual hurricane that circles the planet in an eternal, inescapable spiral. The pressure at the lower cloud layers reaches intensities that would crush any structure that humanity has ever devised, and the chemical reactions occurring within this atmosphere involve compounds that exist only briefly in our most advanced laboratories before destabilizing into their component elements. What makes Upsilon Andromedae be genuinely terrifying is that it exists, that such violent extremes can exist simultaneously on the same world, that nature permits such absolute opposition to coexist without some form of reconciliation or moderation, and that countless versions of this world undoubtedly orbit other stars throughout the universe. Each one a monument to physical extremity and environmental impossibility that makes our own world seem like an improbable sanctuary of moderation and balance. The discovery of such worlds forces us to confront a humbling recognition that Earth's temperate climate, its moderate pressures and survivable temperatures, its delicate balance of day and night, represents not the norm but rather an extraordinary rarity, a narrow band of possibility within an otherwise hostile cosmos where extremes are not the exception but the rule of creation itself. And yet, despite, or perhaps because of, these inconceivable conditions, Upsilon Andromedae B continues its relentless orbit, indifferent to our attempts to categorize it as extreme or impossible, a reminder that the universe operates according to physical laws that care nothing for human notions of habitability or mercy, that permit worlds of such violent contradiction to exist as naturally as our own modest, temperate sphere. In this sense, Upsilon Andromedae B serves as a cosmic mirror, reflecting back to us the profound contingency of our existence, a reminder that life, consciousness, and civilization are not inevitable products of the universe, but rather delicate flowers blooming in the narrow cracks between catastrophe and annihilation, dependent upon conditions so precisely calculated. Deep within the constellation Lyra, approximately 495 light-years from Earth, exists a planetary system that challenges our fundamental understanding of orbital stability and the rules that govern how worlds should behave around their parent stars. The Kepler-442b system contains two planets locked in what astronomers describe as an extraordinarily dangerous gravitational dance, a celestial arrangement so precarious that its very existence seems to violate the principles we once thought immutable. Kepler-442b, a super-Earth or mini-Neptune with a mass roughly 4.5 times that of our own planet, orbits its star every 13.18 days, while its companion Kepler-446c, slightly larger and more massive, completes its orbital journey every 16.23 days. The proximity between these worlds is genuinely alarming, with their orbital paths separated by less than the distance between our own Earth and Moon, bringing them into gravitational contact during their cosmic waltz in a manner that should theoretically result in planetary collision or ejection within millions of years. The psychological mechanism that renders this system so profoundly unsettling operates on multiple levels of human comprehension. When we contemplate planetary orbits, our minds default to the familiar stability of our own solar system, where worlds maintain their distances with predictable regularity across billions of years, suggesting an inherent order and permanence to existence itself. The Kepler-36 system shatters this comfortable assumption, demonstrating that chaos and instability are not aberrations, but rather potential natural states for planetary arrangements. The gravitational perturbations between Kepler-36b and Kepler-36c create oscillations in their orbital parameters, subtle gravitational tugs that accumulate over time like invisible hands slowly pulling two trapeze artists closer together with each swing. This situation manifests as a slow-motion catastrophe, a collision that might take millions of years but remains inevitable unless some mechanism intervenes to stabilize the system or separate these worlds further. We recognize intellectually that such timescales exceed human comprehension entirely, yet somehow this knowledge provides no comfort whatsoever. What persists as remarkable is our continued acceptance of such configurations as standard features of the universe, our casual incorporation of these dangerous systems into the catalog of known exoplanetary arrangements. Astronomers continue discovering similar systems with increasing frequency, worlds balanced on knife edges, maintained through mechanisms we do not fully understand or through pure gravitational chance. We have normalized the idea that the universe is fundamentally unstable, that planetary destruction is not an anomaly but potentially a common outcome, that collision and chaos operate as invisible fundamental forces reshaping planetary systems throughout the cosmos, with indifference to any observer's preference for stability. Yet perhaps this normalization itself represents our most unsettling discovery, that we live not in a universe of exception and rarity, but in one where violent orbital decay, planetary migration, and catastrophic rearrangement are woven into the very fabric of how planetary systems evolve, making Kepler-36 not an aberration, but merely one of countless systems bearing witness to the cosmos's fundamental indifference to permanence or peace. This realization transforms our observation of Kepler-36 from a mere astronomical curiosity into a mirror reflecting the universe's true nature. A cosmos where worlds collide, systems destabilize, and the orderly arrangements we once imagined as permanent prove instead to be fleeting configurations in an endless cycle of gravitational rearrangement. In contemplating Kepler-36b's precarious orbit, we confront not an exception to celestial mechanics, but perhaps the rule itself. Deep within the constellation Serpents, orbiting a millisecond pulsar known as PSR J17191438, exists a world so dense and utterly alien that it defies conventional understanding of what a planet should be. This object, designated PSR J17191438b, is the remnant core of a white dwarf star that was gradually stripped away by the gravitational forces of its pulsar companion, leaving behind a stellar ember composed almost entirely of crystallized carbon and oxygen. What makes this world a prison rather than merely a celestial body is the nature of its composition and the inescapable conditions that define its existence. For nearly the entire mass of Jupiter compressed into a sphere only slightly larger than Earth has been transformed into a solid diamond through unimaginable pressure and heat. The surface temperature oscillates between scorching thermal radiation from the pulsar and the absolute cold of space, creating an environment where no conventional matter could exist in any recognizable form, where the very atoms are crushed and reformed into lattices of pure carbon so tightly bound that nothing could ever escape once pulled into this gravitational well. The pulsar itself, rotating 600 times per second, bathes the diamond world in radiation so intense that it would obliterate any structure capable of existing on conventional planets. Yet the diamond world persists, unchanging and unchangeable, a monument to stellar violence frozen in crystalline form. What creates the psychological weight of this prison is not merely the inhospitable conditions, but the sense of absolute permanence, the understanding that this world will endure in this tortured state for billions of years, neither alive nor dead, neither warm nor cold, existing in a state of perpetual torment orchestrated by the very star it orbits. The mechanism that makes this concept so disturbing is our innate recognition that matter, which we understand to be malleable and transformable, has been locked into a single, eternal configuration, stripped of all possibility of change or evolution. Its destiny sealed the moment the companion star was consumed. We have encountered this world and documented its existence without hesitation, absorbing the knowledge that somewhere in the cosmos, An entire planetary mass has been turned into a prison of its own crystalline structure, and yet we continue to sleep soundly in our beds, knowing that such things exist and might occur far closer than we imagine. That the universe contains mechanisms and forces capable of converting entire worlds into monuments to suffering that will endure without mercy or respite until the stars themselves fade to nothing. Yet perhaps the most unsettling aspect is recognizing that this diamond world was once something else entirely, a living star with its own light, its own warmth, its own potential, and that transformation into this crystalline prison was not instantaneous but gradual, a slow consumption across millions of years as the pulsar's gravity methodically extracted its companion's outer layers. A cosmic process of calcification that mirrors our own fears of inevitable decline and the helplessness of witnessing our own transformation into something unrecognizable. In this way, PSR J17191430 8b becomes not merely an astronomical curiosity, but a mirror held up to our deepest existential anxieties. A tangible reminder that transformation need not be redemptive, that the universe operates according to laws indifferent to suffering, and that even the grandest celestial objects can be reduced to monuments of crystalline captivity. Their former glory erased as completely as footprints in sand, swept clean by an eternal wind. When we consider the fate of Earth's own sun in roughly 5 billion years, its inevitable expansion into a red giant, the consumption of the inner planets, the possible stripping away of Mercury and Venus by stellar winds, we realize that PSR J17191438b is not merely a distant curiosity, but a prophecy written in diamond, a glimpse of the cosmic endgame that awaits all orbiting worlds, transforming the abstract concept of deep time into so. Deep within the constellation Scorpius, approximately 21,000 light-years from Earth, orbits a planet that exists in a state of perpetual absolute desolation, a world so distant from its parent star that it receives virtually no warmth or light, a celestial body known as Ogle 2005 BLG 390 LB, which represents one of the most hostile environments ever theorized to exist within our observable universe. This planet was discovered in the year 2005 through a technique called gravitational microlensing, a method that allowed astronomers to detect its presence by observing the way its massive gravitational field bent light from a distant star, and what they found was a world of such profound isolation and cold that it defies comfortable comprehension. The planet orbits at a distance from its star that places it far beyond what astronomers call the frost line, the theoretical boundary beyond which planetary surfaces remain eternally frozen, and the temperature on its surface is estimated to hover perpetually around -210 degrees Celsius, a cold so extreme that carbon dioxide freezes solid into dry ice, that the very concept of liquid water becomes purely theoretical. And that no known biological process could possibly sustain itself. What makes Ogle 2005 BLG 390 LB so fundamentally terrifying is not merely the extreme cold that dominates its landscape, but rather the complete and utter absence of any energy source that could sustain heat or motion. And this absence creates a psychological void when we contemplate existence on such a world, because the human mind struggles to envision a place so thoroughly devoid of the energetic processes that make reality feel dynamic and alive. The planet likely possesses a surface composed of thick layers of ice and frozen volatiles, concealing beneath perhaps a rocky core, but whether anything exists beneath that frozen crust remains unknowable, and the darkness that surrounds this world would be absolute in every meaningful sense, with its parent star appearing as merely another point of light among countless others, indistinguishable and impossibly distant. Yet despite its utterly inhospitable nature, Ogle 2005 BLG 390 LB continues to exist in this state of frozen suspended animation, circling its star in an eternal dance that will continue for billions of years more, and we have somehow accepted this reality as a normal occurrence within the cosmos, treating it as merely one more data point in our catalog of exoplanets. When in truth it represents a kind of cosmic wasteland so profound that it challenges our fundamental understanding of what a world even is. Perhaps most remarkably, this frozen world serves as a humbling reminder that the vast majority of planets in the universe exist in conditions we would consider absolutely lethal, suggesting that habitable worlds like Earth represent not the norm, but rather a rare and precious anomaly in a cosmos predominantly composed of such desolate, frozen spheres. And in recognizing this cosmic reality, we come to understand that our own world's delicate balance of temperature, atmosphere, and stellar distance represents not an inevitable outcome, but rather an extraordinary convergence of circumstances, making the search for other habitable worlds all the more urgent and meaningful. For they are the true exceptions in a universe dominated by frozen wastelands like Ogle 2005 BLG 390 LB. In this way, Ogle 2005 BLG 390 LB stands as a cosmic monument to the indifference of the universe, a world that will never know the warmth of day or the stirring of life, yet continues its patient orbit as if such distinctions held meaning, reminding us that existence itself requires no audience, no witness, and no purpose beyond the simple fact of being. In contemplating such worlds, we recognize that the universe operates according to physical laws indifferent to our hopes for discovery, and Ogle 2005 BLG 390 LB exemplifies this cosmic neutrality with stark, unrelenting clarity, existing as it does in perfect equilibrium with forces that care nothing for warmth, life, or meaning. In the constellation of Draco, approximately 218 light-years away from Earth, there exists an exoplanet designated HAT P32b that presents astronomers with one of the most perplexing and disturbing phenomena yet discovered in the cosmos. An atmosphere so grotesquely inflated that it defies every conventional understanding of planetary physics and stellar mechanics. This world, roughly the same mass as Jupiter itself, should possess a correspondingly dense and proportionally scaled atmosphere. Yet instead it has developed an envelope of gas so enormously bloated that it extends outward to nearly triple the radius that gravitational theory would predict, creating a celestial body that is fundamentally unstable and seems perpetually on the verge of catastrophic dissolution into the void of space. The planet orbits extraordinarily close to its parent star HAT P32, circling once every 2.15 days in a scorching embrace that bathes the upper atmospheric layers in temperatures exceeding 1,400 Kelvin. And this intense stellar radiation appears to be the mechanism responsible for the extraordinary atmospheric expansion that has puzzled researchers since its discovery in 2011. What makes this phenomenon particularly terrifying is not merely the impossible size of the atmosphere itself, but rather the recognition that we are witnessing a world in active crisis, a planetary body being literally inflated and torn apart by stellar winds and radiation pressure, its atmosphere growing less dense and more diffuse with each passing year as molecules escape into space at rates that suggest the planet may not remain gravitationally coherent indefinitely. The swollen atmosphere of HAT P32b represents a fundamental threat to our understanding of how planets can exist and persist. Yet astronomers continue to observe similar phenomena in other ultra-hot Jupiters, suggesting that this catastrophic atmospheric bloating may be more common than previously imagined, that countless worlds throughout the galaxy may be engaged in this slow, inevitable process of stellar evaporation and gravitational surrender. Their atmospheres expanding outward like the final breath of a dying creature, unable to resist the relentless pull of celestial forces operating far beyond its capacity to endure. In studying HAT P32b and its counterparts, astronomers have begun to recognize that atmospheric escape may represent a critical evolutionary bottleneck for gas giants orbiting close to their stars, fundamentally reshaping our theories about planetary migration, system stability, and the ultimate fates of worlds caught in this cosmic crucible of expansion and loss. These observations compel us to confront an unsettling possibility, that the visible universe contains countless planetary remnants in various stages of atmospheric dissolution, stripped-down cores orbiting as silent monuments to the destructive power of stellar proximity and radiation, each one a cautionary tale written in the language of physics and time. Perhaps most haunting is the recognition that HAT P32b itself may eventually join this graveyard of denuded cores, its swollen atmosphere gradually thinning into invisibility until only a barren rocky remnant remains, a cosmic ghost orbiting its star as eternal testimony to the planet it once was. Yet even in this grim scenario lies a peculiar scientific gift. By studying HAT P32b's atmospheric hemorrhaging in real time, we gain invaluable insights into the mechanisms that shaped our own solar system billions of years ago, transforming a world in its death throes into a cosmic laboratory where we can read the ancient history written in the physics of planetary demise. The protoplanetary disks surrounding young stars like HAT P32 may have harbored dozens of such worlds in their infancy, Yet only those fortunate enough to migrate outward or orbit at greater distances survive to reach maturity, while HAT P32b and its siblings represent the cosmic casualties of orbital mechanics, worlds that wandered too close to their stellar furnaces and paid the ultimate P. Imagine a world where the ground beneath your feet is not solid, not stable, not even remotely permanent in any meaningful sense, but rather engaged in a constant process of violent sublimation, where the very bedrock that constitutes the planet's surface is actively transforming into vapor and dissipating into the atmosphere in an endless, relentless cycle of geological destruction. K2141b, an exoplanet located approximately 200 light-years from Earth in the constellation Cygnus, presents us with precisely this scenario, a world so close to its host star that the surface temperature reaches approximately 3,500 Kelvin, hot enough that rock itself, that most fundamental symbol of permanence and solidity in human consciousness, simply ceases to exist in its traditional state. The planet is tidally locked, meaning one hemisphere perpetually faces the star while the other remains locked in eternal darkness. And on the day side, where temperatures soar to levels that would instantly vaporize any known material in moments, the rocky surface does not melt into lava as one might initially assume, but rather undergoes direct phase transition from solid to gaseous state without passing through a liquid intermediate. A process known as sublimation that transforms stone into wind at the molecular level. The atmospheric pressure on the day side becomes so extreme, so densely packed with vaporized rock that it creates a supersonic wind system circling the planet, winds that exceed the speed of sound itself, carrying with them the evaporated minerals and stone that once formed the crust, perpetually stripping away the surface and redistributing it around the planet in a perpetual cycle. On the night side, this vapor condenses back into rock as temperatures plummet to levels where frozen stone might accumulate, creating a bizarre and nightmarish precipitation of solid rock rain that falls continuously onto the cold hemisphere, building up layers that will eventually rotate back into the day side to be evaporated once more in an eternal geological cycle that repeats itself endlessly. The psychological mechanism behind why this phenomenon is particularly unsettling relates to our fundamental need to perceive the ground as immutable and trustworthy, to understand planets and rocky bodies as the ultimate symbols of constancy and reliability in the universe. Yet K2141b shatters this assumption completely by demonstrating that rock itself is merely another form of matter subject to the extreme conditions of the cosmos. No more permanent than clouds or vapor when subjected to sufficient heat and pressure. We have normalized the idea that planets are essentially eternal, that geological processes operate on timescales so vast that we need not concern ourselves with fundamental transformations. And yet K2141b serves as a reminder that in the universe's most extreme environments, even this normalized assumption crumbles away. And the very concept of a solid planetary surface becomes a meaningless abstraction in the face of stellar radiation, intense enough to break apart the molecular bonds that hold matter in its familiar states. The vast recycling system that characterizes K2141b's surface represents a kind of planetary metabolism unlike anything in our solar system, a living geological process where matter itself becomes as fluid and transient as the atmosphere we breathe, reminding us that permanence is not an inherent property of matter, but merely a temporary condition dependent on environmental circumstances. In contemplating such a world, we are forced to confront the vertigo of truly alien geology, where the very foundations of planetary science must be reconstructed from principles that render our terrestrial assumptions obsolete. Yet perhaps most profoundly, K2141b demonstrates that what we call a planet may be less a discrete object and more a perpetual state of matter in flux, a temporary organization of atoms caught between stellar furnace and cosmic void, suggesting that throughout the universe, worlds exist in states of transformation so extreme that our vocabulary for Imagine standing beneath a sky that is not blue, not gray, not even the familiar shades of terrestrial weather, but instead a deep, unrelenting yellow that extends from horizon to horizon in every direction you turn, a yellow so saturated and pervasive that it seems to have become the very definition of light itself on this distant world. WASP-79b orbits its parent star at a distance that places it firmly within the range of what astronomers call a hot Jupiter, a gas giant that has migrated inward from the cooler regions of its system and now completes its orbit in merely 3.5 days, subjecting its upper atmosphere to temperatures that exceed 1500 Kelvin. Hot enough that traditional concepts of day and night become almost meaningless when the star dominates the sky with such relentless intensity. The yellow color that characterizes this world's appearance comes not from some exotic atmospheric compound alone, but rather from the way sodium atoms and potassium atoms, vaporized and excited by the intense stellar radiation, scatter light across the visible spectrum in a manner that overwhelms our perception with yellow wavelengths, creating an alien chromatic environment that no human eye has ever witnessed in person, yet remains profoundly real, profoundly present. Orbiting a distant star approximately 870 light-years away from Earth. The psychological mechanism behind why such a world unsettles us, even when we observe it only through data and spectroscopic analysis, seems to stem from our deep evolutionary familiarity with Earth's blue sky, a color associated with breathable atmosphere, stable conditions, and the comfort of a world where life can flourish, so that when we encounter the concept of a yellow sky so complete and overwhelming, our minds struggle to reconcile this with any framework of habitability or safety, triggering an instinctive unease at the violation of expectations we carry about what a world should look like. We have normalized the idea that all planets should resemble Earth in their basic chromatic properties, that yellow is merely a transitional color in weather systems rather than a permanent atmospheric condition, and yet WASP-79b persists in defiance of these comfortable assumptions, a yellow world where no human could stand, where no life as we understand it could evolve. Existing not through any mistake or misunderstanding on our part, but through the straightforward physics of stellar radiation meeting atmospheric chemistry, a reminder that the universe contains wonders and horrors in equal measure, indifferent to our preferences or our psychological comfort. Yet perhaps this very indifference is the greatest gift science offers us. The permission to stand in awe before something that asks nothing of us except to acknowledge its existence, to accept that beauty and habitability need not be synonymous, and that a yellow sky burning beneath an alien sun represents not a failure of creation, but rather an expansion of what creation permits, an expansion that ultimately enriches our understanding of what is possible in the cosmos. In this way, WASP-79b Yellow Sky becomes not merely an astronomical curiosity, but a philosophical mirror, reflecting back our assumptions about the relationship between beauty, life, and the fundamental nature of worlds, inviting us to expand our sense of wonder beyond the familiar boundaries of Earth's biosphere and into the vast spectrum of possibilities that await in the depths of space. And when we finally develop the instruments to observe such worlds in even greater detail, to map the swirling patterns of their yellow clouds and trace the circulation of their superheated winds, we may discover that this alien chromatic palette tells stories of atmospheric dynamics and chemical processes that challenge our current models of planetary science, reminding us that every world, no matter how hostile or strange, offers lessons that reshape our understanding of what physics and chemistry can accomplish when given the vast canvas of an exoplanet to work upon. Deep within the outer reaches of our solar system, approximately 2.8 billion miles from Earth, exists a world of such violent atmospheric turbulence that the very concept of stable weather becomes meaningless, a place where the winds move at velocities that defy our terrestrial understanding of meteorological possibility. Neptune, that distant ice giant shrouded in perpetual darkness and swirling methane clouds, experiences wind speeds that routinely exceed 2,000 kilometers per hour, making it the most tempestuous planetary body in our entire solar system. Yet paradoxically, we know remarkably little about the specific mechanisms that generate and sustain these supersonic currents. The winds of Neptune move at speeds that would disintegrate any aircraft humanity has ever constructed within microseconds, winds that travel faster than the speed of sound in Earth's atmosphere, yet they persist in an environment where no obvious energy source seems adequate to maintain such catastrophic velocities. When we observe Neptune through our telescopes and spacecraft instruments, we see enormous storm systems and atmospheric bands that swirl and collide with one another in patterns of such organized chaos that they appear almost deliberately designed to maximize atmospheric turbulence rather than achieve any form of equilibrium. The scientific explanation points to internal heat sources, the residual thermal energy left over from Neptune's formation billions of years ago, combined with the planet's rapid rotation and the complex interactions between its upper atmosphere and lower atmospheric layers. Yet even accounting for these factors, the sheer intensity and persistence of these winds seems to exceed what our models predict should be possible under these conditions. What makes Neptune's supersonic winds particularly unsettling to contemplate is that beneath the visible cloud layers, in the darkness and pressure where no light penetrates, these winds continue to exert their force upon layers of atmosphere composed of hydrogen, helium, and methane, creating structures and turbulence that we will likely never directly observe or fully understand. The psychological impact of contemplating such a phenomenon derives partly from the recognition that here exists a world where conditions are so extreme that they render our standard frameworks of understanding almost useless, where even our most sophisticated instruments can only detect and measure phenomena that our minds struggle to truly conceptualize in any meaningful way. We have normalized this knowledge of Neptune's winds because they exist so far beyond our reach, because they pose no direct threat to human life, and because our culture has relegated the outer planets to the category of abstract scientific curiosities rather than viscerally terrifying places that actual physical objects might someday encounter. At the moment one truly engages with the reality that winds of such magnitude exist, that they have persisted for billions of years, and that they would obliterate any structure or organism with incomprehensible speed and force. The comfortable distance between ourselves and Neptune begins to collapse in the imagination, leaving only the awareness that our solar system contains forces and conditions fundamentally inimical to any form of life or stability as we understand it. The winds of Neptune serve as a humbling reminder that our planet's meteorological systems, even in their most violent manifestations, hurricanes that devastate coastlines, tornadoes that tear through continents, represent merely the gentlest whisper of what atmospheric dynamics are capable of producing when conditions align differently, a recognition that should inspire both scientific curiosity and existential humility in equal measure. When we consider that a hurricane on Earth might sustain winds of 300 kilometers per hour, and we regard it as catastrophic, the realization that Neptune's winds move nearly 7 times faster with no possibility of dissipation or escape renders our conventional measures of disaster almost quaint by comparison. Imagine a world so close to its star that the concept of night has become entirely theoretical, a place where the surface temperature reaches nearly 2,000 degrees Fahrenheit in a perpetual state of stellar bombardment that would vaporize any known form of matter within microseconds of exposure. This is 51 Pegasi b, a gas giant orbiting so tightly around its parent star that it completes an entire revolution in just 4 days, locked in an orbital embrace so intimate that tidal forces have frozen one hemisphere in an eternal, roasting daylight while the other side endures an equally eternal twilight of unimaginable heat. The discovery of this world in 1995 fundamentally shattered our assumptions about how planetary systems could possibly be organized, because everything we observed in our own solar system suggested that gas giants should exist far from their stars, dwelling in the cold outer reaches where gravitational dominion over distant ice and rock made logical sense. Yet here was 51 Pegasi b, a hot Jupiter of staggering proportions, orbiting so aggressively close that its atmospheric layers experience temperatures capable of melting lead, with winds moving at supersonic velocities that rage across a surface we cannot even properly perceive, driven by temperature differentials so extreme that the physics governing such weather systems barely registers within our computational models of planetary behavior. The psychological impact of confronting such a world lies in recognizing that the rules we thought were immutable, the ordering principles we believed governed the formation and arrangement of planets around distant suns, were nothing more than our narrow experience extrapolated outward as universal law. We had observed one system, our own, and built entire theoretical frameworks suggesting that what we saw locally must be what nature preferred globally. Yet 51 Pegasi b demonstrated with absolute clarity that nature has no preference for our comfort or our expectations, that planetary systems can arrange themselves in ways that contradict everything we felt certain about, and perhaps most disturbingly, that there are likely countless worlds we have never imagined existing in configurations we cannot yet comprehend even now that we know such arrangements are possible. What persists despite this knowledge is our continued tendency to assume that the universe operates according to principles we can eventually master and predict, even as each new discovery pulls back another layer of our ignorance and reveals new mechanisms of cosmic organization that dwarf our previous understanding in scope and complexity. Yet 51 Pegasi b remains merely the first of thousands of exoplanets we have catalogued, each one a reminder that the universe's creativity vastly outpaces our capacity to anticipate it, and that humility in the face of such cosmic abundance may be the only rational response to a cosmos that continues, with patient indifference, to exceed the boundaries of our imagination. And yet, when we turn our instruments toward 51 Pegasi b itself, we confront the sobering reality that this world remains fundamentally unknowable to us, a sphere of roiling gases and incomprehensible violence that we can only observe from across a gulf of 50 light-years, reduced to a mere fluctuation in starlight, a gravitational whisper detected through the Doppler shift of its parent star's motion. Our knowledge of it forever limited to abstract data points and mathematical abstractions that bear no resemblance to the visceral reality of what actually occurs in that hellish orbital furnace. Yet perhaps this very distance, this unbridgeable gulf between observer and observed, is precisely what grants 51 Pegasi b its profound significance, for in remaining forever beyond our direct perception, it forces us to confront the limits of human knowledge itself, transforming a distant exoplanet into a mirror reflecting back our own epistemological humility in the face of a universe that will always contain mysteries we can only approximate through mathematics and inference. Among the exoplanets that astronomers have catalogued in their vast databases of distant worlds, few possess physical properties quite as unsettling as those of Kepler-7b, a gas giant located approximately 1,000 light-years from Earth in the constellation Lyra, a world whose density is so extraordinarily low that it rivals the density of Styrofoam, that ubiquitous packing material we find in shipping boxes and takeout containers. Kepler-7b, despite being a planet with a mass roughly 1.5 times that of Jupiter, possesses a radius that stretches to nearly 1.5 times Jupiter's radius, creating a planetary body so diffuse, so lacking in gravitational compression, that its overall density falls to approximately 0.3 grams per cubic centimeter, a figure so remarkably low that the planet would theoretically float in water if such a cosmic bathtub existed. The discovery of this world challenged fundamental assumptions about planetary formation and composition, forcing astrophysicists to reconsider the mechanisms by which such massive bodies could remain so extraordinarily light, so devoid of the crushing density typically associated with gas giants that had been observed around other stars. The mechanism behind this peculiar density relates to the extreme atmospheric inflation that occurs when a gas giant orbits so close to its host star that intense radiation and stellar winds cause the planet's atmosphere to expand dramatically, heating the upper layers of the atmosphere to temperatures exceeding 1500 Kelvin, causing the gaseous envelope to swell outward in a phenomenon known as atmospheric bloat or planetary puffiness. This process effectively creates a planetary body that is mostly empty space, a world composed predominantly of hydrogen and helium stretched across an enormous volume, resulting in the counterintuitive situation where a planet substantially more massive than Jupiter occupies a space so vastly expanded that its average density becomes absurdly low, comparable to the friable, porous structure of expanded polystyrene foam used in packaging materials worldwide. What persists as truly disturbing about Kepler-7b, despite the logical explanations provided by stellar radiation and atmospheric physics, is the visceral wrongness of contemplating a world of such immense gravitational pull, yet such insubstantial density, a planet that represents a kind of cosmic paradox where tremendous mass creates almost no gravitational field relative to its size. A body that defies the intuitive relationship between mass and presence that we experience on Earth, where density and substance feel synonymous with significance and impact. Yet this planetary anomaly serves as a humbling reminder that the universe operates according to principles far more nuanced than our earthbound intuitions suggest, and that mass and density need not correlate in the ways our everyday experience has conditioned us to expect, revealing a cosmos far stranger and more intricate than our comfortable assumptions would allow. In this sense, Kepler-7b stands as a testament to the profound strangeness that awaits us in the depths of space, a world that transforms our understanding of what a planet can be, and invites us to embrace the humbling recognition that the universe's inventory of possibilities far exceeds the constraints of our terrestrial experience. And perhaps this is the deepest lesson that Kepler-7b offers, that our categories and classifications, our neat divisions between the substantial and the ephemeral prove inadequate when confronted with the full spectrum of cosmic diversity, and that wonder itself may lie not in confirmation of our expectations, but in their gentle, persistent dissolution. In observing Kepler-7b, we are reminded that the universe does not defer to our categorical preferences, and that phenomena once deemed impossible, a planet less dense than the material we crumple and discard, now demands our careful reconsideration and intellectual humility. Approximately 240 light-years from Earth, orbiting the star HD 149026, exists a world so fundamentally alien in its thermal properties that it challenges our basic understanding of planetary behavior and stellar interaction. HD 149026b is a hot Jupiter, a gas giant roughly the mass of Saturn that orbits its parent star in just 3.5 days, placing it closer to its sun than Mercury is to our own. Yet what makes this world truly disturbing is not merely its proximity to its star, but rather its inexplicable and almost impossible capacity to absorb light in ways that defy conventional astronomical expectation. When astronomers first observed this exoplanet using the Spitzer Space Telescope, they discovered something profoundly unsettling about its reflectivity and heat distribution patterns. Rather than reflecting a significant portion of the stellar radiation it receives, as theory would suggest it should, HD 149026b appears to absorb an extraordinarily high percentage of the incoming light from its parent star, converting it into heat that radiates away into the cold vacuum of space, creating a kind of cosmic furnace that seems to operate with almost deliberate efficiency. The planet's dayside temperature reaches approximately 2000 degrees Kelvin, hot enough to vaporize metals and create an atmosphere of superheated gas that swirls in perpetual, violent circulation patterns. What troubles scientists most profoundly is the mechanism behind this absorption, for the planet's composition and atmospheric structure should theoretically reflect more light back into space, yet somehow it does not, as though the very laws of thermodynamics are operating differently in this distant system, or as though the planet itself has been engineered to consume radiation with calculated precision. The psychological impact of contemplating such a world stems from our deep, intuitive understanding that matter should behave in predictable ways, that the laws of physics are universal and immutable, and that we can rely upon our models to explain what we observe in the cosmos. Yet HD 149026b represents a fundamental challenge to these comfortable assumptions, for here exists a world that seems to deliberately contradict our expectations, absorbing heat with an almost purposeful intensity that suggests either our understanding of planetary atmospheres is incomplete, or that we are observing something so far removed from our terrestrial experience that we lack the conceptual framework to fully comprehend it. The mechanism driving this fear is rooted in the recognition that a world capable of absorbing nearly all light that strikes it is a world of profound hostility and finality, where nothing that falls into its gravity well will ever escape, where all energy is consumed and converted into raw, unforgiving heat. This triggers in the human mind a primal anxiety about being drawn into something from which there is no return, a kind of cosmic predator that feeds on light itself and generates an infernal heat that would obliterate any spacecraft or probe unfortunate enough to approach it. We have normalized our understanding of exoplanets as distant curiosities, mathematical abstractions represented in data tables and academic papers. Yet when confronted with the reality of a world that seems to exist for the purpose of destroying everything that touches it, we are forced to confront the possibility that the universe contains not merely inhospitable places, but places that are actively hostile to existence itself. Places so thoroughly inhuman that our minds struggle to fully grasp their terrible nature. The true horror lies not in HD 149026b's existence alone, but in the knowledge that countless worlds like it may populate the galaxy, each one a silent monument to the universe's profound indifference to the survival of conscious life, reminding us that habitability is not the default state of planetary systems, but rather an improbable accident confined to rare corners of an overwhelmingly hostile cosmos. In the constellation Andromeda, approximately 470 light-years from Earth, orbits a celestial body that has fundamentally challenged our understanding of planetary atmospheres and the mechanisms by which worlds protect themselves from stellar radiation. WASP-33b, a massive hot Jupiter exoplanet that circles its parent star in a dangerously tight orbital dance, possesses an atmosphere so chemically reactive and thermodynamically unstable that it functions less like a traditional atmosphere and more like a continuous catastrophic chemical reaction perpetually broadcasting its agony across the cosmos. What makes this world particularly terrifying is not merely the surface temperature that reaches nearly 4,000 degrees Fahrenheit, nor the crushing pressures that would instantly obliterate any conceivable spacecraft, but rather the presence of exotic molecules that form and reform in rapid succession as they circulate through zones of extreme temperature variation. The atmosphere contains titanium oxide and other metallic compounds that behave like microscopic particles of sunscreen, reflecting and absorbing the relentless stellar radiation that batters the planet's day side with the intensity of thousands of suns. Yet these reflective particles do nothing to ease the planet's fundamental torment. They merely redistribute the thermal energy in ways that create violent wind patterns and atmospheric shear that would tear apart any structure composed of materials we understand. The psychological mechanism underlying our fear of WASP-33b concerns the realization that planetary atmospheres, which we have long conceptualized as protective blankets surrounding vulnerable worlds, can instead become mechanisms of perpetual suffering, dynamic systems that are not designed to preserve, but rather to fail continuously while attempting to protect themselves. The atmosphere does not settle into equilibrium, but instead maintains a perpetual state of chemical warfare between competing molecular reactions, with molecules constantly being destroyed by radiation and reformed in different configurations, creating a kind of atmospheric turnover that occurs on timescales of mere hours rather than the geological timescales familiar to us from studying terrestrial worlds. What is perhaps most deeply unsettling is that WASP-33b's atmosphere, despite being fundamentally hostile to any form of life, and despite continuously losing molecules to space through a process called atmospheric escape, persists in its attempt to shield the planet from its star, as if the world itself is trapped in an eternal cycle of futile self-protection, expending vast amounts of energy on a defense that fails perpetually and must be renewed with each rotation. We observe in WASP-33b's desperate atmospheric struggle a mirror of our own planetary anxieties. The recognition that even the grandest natural defenses against cosmic forces operate on borrowed time, ultimately surrendering their constituent molecules to the void, and that somewhere in the universe, a world continues its futile vigil against annihilation, asking nothing but to persist in its suffering. In this light, WASP-33b becomes not merely a distant astronomical curiosity, but a meditation on resilience itself, a planet that has survived for millions of years despite possessing none of the conditions we associate with stability, suggesting that persistence need not require success, only the inexhaustible willingness to continue existing against impossible odds. And in the end, this is perhaps the truest lesson WASP-33b offers to those patient enough to study it, that the universe does not reward planets for their suffering, nor does it punish them for their struggle, but simply permits them to exist in whatever form their physics allows, asking only that they continue their impossible dance until the day their star finally exhausts itself and grants them the silence they have never known. Proxima Centauri, the closest star to our Sun at just over 4 light-years away, is a red dwarf that orbits with a terrestrial exoplanet called Proxima b in its habitable zone. Yet this proximity to a star that appears deceptively calm from our distant vantage point conceals a reality far more violent than most stellar systems we have observed and studied. The star itself is prone to unpredictable and catastrophic stellar flares, sudden releases of magnetic energy that erupt from the star's surface with intensities that can temporarily increase the star's brightness by several magnitudes and flood the surrounding space with deadly radiation across multiple wavelengths, including ultraviolet light, X-rays, and energetic particles that would obliterate most forms of unprotected biological life in moments. Proxima b, locked in a tidally bound orbit where one hemisphere perpetually faces its star while the other remains in eternal darkness, receives the brunt of these flares in concentrated bursts that strip away at any planetary atmosphere molecule by molecule, exposing the surface beneath to ionizing radiation that would render any organism's DNA into damaged, non-functional strands within seconds of exposure. The psychological mechanism that makes this scenario so profoundly terrifying operates through our understanding that proximity itself becomes the mechanism of destruction, that being closer to the potential source of life somehow inverts into becoming closer to obliteration, creating a paradox where the very conditions that might theoretically support life actively work to annihilate it with relentless, mechanical indifference. We have normalized the idea that habitable zones represent safety and opportunity, yet Proxima b demonstrates that orbital position alone offers no shelter when the star itself becomes an erratic weapon, sending waves of radiation that no geological barrier or atmospheric shield could reasonably withstand for extended periods. The planet persists in this orbit despite these flares not through any protective mechanism, but through sheer gravitational inevitability, condemned to remain where physics demands it remain, receiving bombardment after bombardment from a star that shows no mercy and requires no reason to unleash its fury. Each flare event represents a reset button for any nascent chemistry that might accumulate on Proxima b's surface, a cosmic erasure that transforms the planet into a sterilized, lifeless anvil, where the very atoms are knocked into new configurations by the sheer violence of stellar radiation, rendering the concept of biological evolution or chemical complexity virtually impossible across timescales that would matter for the emergence of life. Yet despite this hostile portrait, Proxima b remains a subject of intense scientific scrutiny precisely because it forces us to confront the limits of habitability itself, to recognize that the universe's capacity to generate worlds does not correlate with its capacity to nurture them, and that some celestial bodies exist as monuments to the principle that proximity to a star, however theoretically advantageous, offers no guarantee against becoming a barren, radiation-scoured wasteland where the only constant is the violent indifference of stellar physics. In this sense, Proxima b becomes a cautionary tale written across the cosmos, a reminder that the search for habitable worlds must account not merely for orbital distance and liquid water, but for the temperament of the star itself, for a red dwarf's apparent dimness masks a capacity for destructive outbursts that can render even theoretically favorable circumstances catastrophically inhospitable within moments of a single stellar convulsion. The discovery of additional planets in the Proxima system, Proxima c and the candidate Proxima d, only deepens this sobering lesson, suggesting that even systems blessed with multiple worlds remain fundamentally shaped by the temperamental nature of their central star, where habitability becomes less a property of celestial geography and more a question of stellar mercy. Io stands as perhaps the most volcanically active celestial body within our solar system, a moon orbiting Jupiter that experiences a level of geological fury that defies conventional understanding of planetary mechanics. The surface of this distant world is dominated by hundreds of active volcanic structures that erupt continuously, spewing sulfurous compounds and molten material across the landscape in a perpetual display of destructive energy that has persisted for billions of years without cessation. The temperatures within these volcanic vents reach thousands of degrees, creating a surface environment so hostile and inhospitable that no conventional spacecraft could ever land there and survive for more than moments. Yet these eruptions continue relentlessly, as though driven by some unknowable force beneath the moon's thin, fragile crust. The mechanism behind this eternal volcanism originates from the gravitational interactions between Io and Jupiter itself, combined with the orbital dynamics it shares with neighboring moons Europa and Ganymede, creating a tidal heating effect so powerful that the interior of Io remains perpetually molten and churning. This tidal friction generates enough heat to maintain a subsurface ocean of magma, an entire planetary layer of liquid rock that never cools, never solidifies, and continuously drives the volcanic activity upward toward the surface in an endless cycle of eruption and reformation. What makes this particularly unsettling is that we have observed Io through numerous space missions over decades, documenting its volcanic features with increasing detail and clarity, watching as the surface literally reshapes itself before our eyes with new volcanic deposits covering old ones. And yet, despite our complete scientific understanding of the mechanisms that drive this activity, we continue to regard it with a sense of wonder tinged with existential dread. As though recognizing that here exists a world operating under physical laws that allow for such extreme and continuous destruction without any biological consequence, because nothing could possibly exist there to be destroyed. Yet perhaps this is precisely what renders Io so compelling to our scientific imagination. a world where destruction and creation occur simultaneously and without restraint, where the very ground beneath us would instantaneously vaporize any matter we might place upon it, and where the only constant is change itself, measured not in geological epochs, but in the span of mere years, as entire mountain ranges rise and fall in the volcanic crucible. The Prometheus volcano, observed continuously since the Voyager missions of 1979, exemplifies this relentless transformation, a plume that has persisted for decades, yet the underlying vent itself shifts and migrates across the surface as the volcanic landscape reorganizes itself beneath its own eruptions. In this way, Io becomes not merely a world of volcanic activity, but a testament to the raw power of physics itself, a place where the cosmos conducts an experiment in perpetual metamorphosis on a scale that renders human timescales almost meaningless. When we observe the sulfur dioxide plumes reaching heights of 500 kilometers above Io's surface, or detect the infrared signatures of lava lakes that dwarf anything in Earth's geological record, we are witnessing not anomalies, but the fundamental expression of a world where the boundary between creation and annihilation has become so blurred as to be meaningless, where geology itself transcends into something approaching the sublime. The sulfur frost that blankets Io's polar regions, deposited by countless eruptions over geological time, creates a landscape of otherworldly beauty, crimson and yellow plains interrupted by dark volcanic calderas. Yet this aesthetic veneer masks an environment of such chemical and thermal extremity that it exists almost as an alien world within our own solar system. A place that challenges our very definition of what constitutes a habitable planetary surface, and reminds us that life, as we understand it, represents merely one narrow possibility within the vast spectrum. Beneath the perpetually orange haze of Titan's atmosphere lies a landscape more alien and fundamentally incomprehensible than anything humanity has yet encountered in the solar system. A world where the very concept of liquid water as a sustaining force has been replaced entirely by vast seas and lakes composed of liquid methane and ethane. Substances that exist in gaseous form under Earth's conditions, but pool and flow across this distant moon's surface with the same familiarity that oceans occupy our own planet. The Cassini spacecraft has documented these methane seas with meticulous detail, revealing sprawling bodies of liquid hydrocarbons concentrated primarily in the polar regions, where temperatures plunge to approximately 94 Kelvin, cold enough that methane transitions from gas to liquid as naturally as water condenses in Earth's clouds, and these seas stretch across thousands of kilometers, with Kraken Mare alone covering an area larger than the Caspian Sea. A body so vast and so profoundly real that it exists as verifiable geographical feature on maps of this moon, mapped and measured and documented as thoroughly as any earthly ocean. The psychological impact of comprehending these methane seas stems from a fundamental violation of our intuitive understanding of planetary habitability and the nature of life itself, because we have evolved with an absolute conviction that liquid water represents the universal solvent and fundamental requirement for any conceivable form of biochemistry. Yet Titan presents a scenario where an entirely different chemistry operates, where waves composed of liquid methane crash against shorelines of water, ice as hard as granite, where weather patterns driven by methane evaporation and precipitation mirror our own hydrological cycle in every structural detail, except for the substitution of the primary chemical involved. What makes this scenario particularly destabilizing to contemplate is the realization that if methane seas can exist and persist on Titan, maintaining complex systems of circulation and evaporation and weather patterns, then the categorical insistence that life requires water becomes less a universal law and more a parochial limitation of Earth's particular history. And this conceptual shift forces us to acknowledge that we have constructed our understanding of possibility around the specific conditions of our own world, projecting our experience outward as if it represented cosmic truth rather than merely local circumstance. The seas of Titan persist in our collective indifference despite this profound implication, despite the fact that they represent nothing less than a complete reversal of everything we assumed we knew about planetary chemistry and the prerequisites for complex liquid systems, because we have somehow managed to absorb this information into our existing frameworks without genuine integration. We have filed it away as an interesting curiosity rather than as a fundamental challenge to our epistemological assumptions about what the universe can and cannot contain, And this normalization of the extraordinary represents perhaps the deepest psychological phenomenon at play. The way that even the most alien and impossible vistas, once documented and named and placed on maps, gradually lose their power to genuinely disturb us, settling instead into that comfortable category of weird facts that we acknowledge without truly comprehending. We know that Krakenmeer exists, that its shores have been mapped by radar, that hydrocarbon rainfall feeds its depths in a cycle as old as Titan itself. Yet this knowledge produces in us only a mild intellectual satisfaction, rather than the vertigo that should accompany the recognition that we have fundamentally misunderstood the basic conditions under which complex planetary systems can operate. And perhaps this represents the final triumph of habituation over insight. That even when confronted with liquid worlds composed of substances we associate only with fuel and industrial byproducts, we simply add them to our catalog of facts and move forward, our capacity for genuine wonder already exhausts. Imagine a world where the very air you breathe is being systematically torn away from the planet itself, molecule by molecule, streaming out into the void of space in a continuous and unstoppable hemorrhage that will eventually leave nothing behind but a barren, scorched rock devoid of any atmosphere whatsoever. And this is the reality facing HD 209458b. A hot Jupiter located approximately 47 light-years from Earth in the constellation Pegasus, a gas giant that orbits so perilously close to its parent star that it completes an entire revolution in just 3.5 days, subjecting the planet to temperatures that exceed 1,200 Kelvin and creating conditions of such extreme heat that the outermost layers of the planet's atmosphere have begun to evaporate and escape into space at a rate of hundreds of thousands of tons per second. The mechanism driving this catastrophic atmospheric loss operates through a process known as photoevaporation, wherein the intense ultraviolet radiation and extreme stellar winds emitted by the star bombard the upper atmosphere of the planet with such ferocity that they impart enough energy to overcome the gravitational pull that would otherwise keep those atmospheric particles bound to the world, and once this threshold is crossed, the lighter elements like hydrogen and helium simply drift away permanently, creating a vast expanding envelope of gas around the planet that glows faintly with the ultraviolet light of the star, a phenomenon that astronomers have observed directly through spectroscopic analysis that reveals the telltale signatures of hydrogen gas escaping from the planet's upper atmosphere. What makes this scenario particularly unsettling from a conceptual standpoint is that this process is not a temporary phenomenon or an aberration that might reverse itself over time, but rather an inevitable and ongoing consequence of the planet's orbital configuration and stellar environment, a slow and inexorable process that will continue for millions of years, gradually stripping away the atmosphere layer by layer until eventually all that remains is the dense core of the planet. A dead and airless world orbiting a star that once provided the energy to sustain an atmosphere, yet the universe continues this grinding process without pause or deviation, indifferent to the consequences and unbothered by the transformation occurring before our instruments, a reminder that planetary destruction operates on timescales and through mechanisms entirely separate from human concern or comprehension. Yet this planetary death is not unique. Similar atmospheric escape is occurring around countless other hot Jupiters throughout the galaxy, suggesting that the violent stripping of atmospheres may be a common fate for planets that venture too close to their stars, a universal process of celestial erosion that reshapes worlds across the cosmos in ways we are only beginning to understand. And indeed, HD 209458b itself has likely lost a significant fraction of its original atmosphere over the millions of years it has orbited its star, with some models suggesting that it may have begun as a more massive gas giant before photoevaporation systematically diminished its envelope, transforming it into the relatively depleted world we observe today and offering us a glimpse into the ultimate fate that awaits countless other planets trapped in similarly punishing orbital geometries throughout the universe. This process of atmospheric erosion reveals a profound truth about planetary evolution, that the initial conditions of a world's formation matter far less than its subsequent orbital history, and that proximity to a star can transform even a gas giant into a stripped remnant, serving as a cautionary tale written across the cosmos in escaping hydrogen and helium. The discovery of HD 209458b's atmospheric escape has fundamentally altered our understanding of planetary demographics, forcing astronomers to reconsider whether observed exoplanet populations reflect the true diversity of worlds that formed, or merely the survivors of atmospheric stripping that elim. Imagine a world where one side of the planet faces its star in perpetual daylight, while the other side remains locked in eternal darkness. And this is the reality of TRAPPIST-1b, an exoplanet orbiting within the habitable zone of an ultra-cool dwarf star located approximately 40 light-years away in the constellation Aquarius. The planet is tidally locked, meaning that the same hemisphere always faces its parent star due to gravitational forces that have synchronized its rotation with its orbital period, creating a configuration where one face experiences endless scorching radiation while the other plunges into absolute freezing shadow. On the sunlit side, temperatures could climb to levels where water boils away into the atmosphere and rock begins to soften, while on the dark side, temperatures plummet to such extremes that carbon dioxide and methane would condense into solid frost upon the surface. The terminator line, that theoretical boundary between day and night, would create a narrow twilight zone where temperatures might theoretically support liquid water. Yet even this habitable band exists in a state of perpetual flux and instability. What makes this scenario psychologically unsettling is not merely the extreme conditions themselves, but rather the fundamental violation of the planetary rhythms we have evolved to understand instinctively. We are creatures of worlds with day and night cycles, with seasons and rotations that mark time and create predictability. The idea of standing on TRAPPIST-1b and knowing that you could never experience a sunset or sunrise, that the sun would never move across your sky, that your entire existence would be defined by either burning daylight or absolute darkness, challenges something deep within our conceptual framework of what a habitable world should resemble. We have normalized the assumption that planets must rotate, must have day-night cycles, must experience some form of temporal variation and rhythm, yet tidally locked worlds represent perhaps the most common configuration for planets orbiting close to their stars, suggesting that in the universe at large, our Earth-like rotational properties are perhaps the unusual exception rather than the rule. Despite this knowledge, despite understanding the physics and probability, we continue to unconsciously expect habitable worlds to function like our own, with turning seasons and moving suns, and the comforting progression from light to darkness and back again. Unable to fully integrate the reality that most potentially habitable exoplanets may never experience anything resembling the circadian rhythms that define life as we know it. Yet perhaps this cognitive dissonance itself reveals something important, that our search for extraterrestrial life, no matter how scientifically rigorous, remains fundamentally filtered through the lens of our own planetary experience, and we may be overlooking entire biospheres that have evolved under conditions so alien to our intuition that we lack even the conceptual vocabulary to imagine them. Perhaps a creature evolved in TRAPPIST-1b's twilight band would experience time not as a cycle of rising and setting, but as an eternal present moment, where survival depends not on anticipating seasonal change, but on navigating the knife-edge equilibrium between two infinities of temperature, transforming what we perceive as cosmic monotony into an intricate dance of microclimatic variation that structures an entire world's complexity. In such an environment, the wind patterns created by the temperature differential between day and night sides would become the planet's primary organizing force, a perpetual atmospheric circulation that might serve the same ecological role that seasons do on Earth, creating corridors of migration and resource distribution for any life form resilient enough to inhabit this alien equilibrium. To truly understand TRAPPIST-1b would require us to abandon our assumption that habitability requires variety, and instead recognize that monotony and extreme specialization might themselves be the crucibles within which the most exotic and unfamiliar forms. Kepler-16b orbits a binary star system, meaning it circles not one sun but two stars locked in gravitational dance with one another. And this creates a phenomenon so fundamentally disorienting to our terrestrial understanding that it challenges the very way we conceptualize day and night, light and darkness, and the basic rhythms that govern existence itself. The planet receives illumination from both stellar bodies simultaneously, yet because these stars orbit each other at different distances and speeds, there are moments when one star passes directly in front of the other from the perspective of the planet's surface, creating what astronomers call a double eclipse or double shadow, where the world below falls into a darkness so complete and so temporally irregular that it defies the predictable cycles upon which all life depends. Imagine standing on the surface of this world during what you believe to be daylight, with both suns visible in the sky, their combined light creating a landscape bathed in harsh brilliance, only to have one massive stellar body slide silently and inexorably in front of its companion, stealing the light incrementally until you stand in complete darkness in the middle of what should be your brightest hours. Unable to predict when this will happen because the orbital mechanics of binary stars create eclipse patterns of such complexity that they resist simple forecasting. The psychological mechanism at work here involves our species' fundamental dependence on reliable celestial patterns, a dependence so ancient and so deeply encoded into our neurobiology that we experience the violation of these patterns as something approaching existential dread. Yet the systems that create such violations in binary star systems are not aberrations or failures of physics, but rather are expressions of the same gravitational laws that govern our own solar system. And on a world like Kepler-16b, life would necessarily evolve under conditions of perpetual temporal uncertainty, where the very concept of a reliable day-night cycle becomes meaningless, and organisms would have no choice but to develop metabolic and behavioral systems entirely alien to anything we recognize as viable life. And yet, from a thermodynamic perspective, there is nothing inherently preventing the emergence of biological complexity under such conditions. Only our inability to imagine it. What persists despite its profound incompatibility with our terrestrial experience is the reminder that the universe operates according to principles entirely indifferent to our comfort or comprehension, and we have normalized the existence of such worlds through the casual language of astronomy, referring to double shadows as merely interesting orbital configurations, when in truth they represent a fundamental fracturing of the environmental predictability that we have unconsciously assumed to be a prerequisite for any form of biological existence. Yet thousands of exoplanets discovered in recent decades orbit binary systems, suggesting that if life has emerged elsewhere in the cosmos, it has done so under conditions of shadow doubling and light theft that our minds struggle even to visualize, let alone accept as harboring the possibility of worlds teeming with living things. And perhaps this is where our deepest realization emerges, that the strangeness we perceive in binary star systems is not a property of those systems themselves, but rather a measure of how narrow the band of our own experience truly is, how contingent our entire framework for understanding life has become upon the accident of orbiting a single, reliable star, and how readily we mistake the particular conditions of our own world for universal prerequisites rather than the statistical outliers they may very well be. The inhabitants of Kepler-16b, should they exist, would possess no mythology of a dependable sun, no ancient calendars carved into stone to track a reliable celestial order, and their entire philosophical understanding of time itself would rest upon foundations so fundamentally different from ours that we might not even recognize their temp. Approximately 130 light-years away from Earth, orbiting a young star in the constellation Pegasus, exists a world that defies our conventional understanding of habitability, a gas giant designated HR 8799e, whose atmosphere represents one of the most inhospitable chemical environments we have ever observed in our expanding catalog of exoplanets. This world, discovered in 2010 through direct imaging techniques that allowed astronomers to actually see the planet's faint infrared glow against the brightness of its parent star, possesses an atmosphere so fundamentally toxic and chemically turbulent that the very concept of falling asleep beneath such skies becomes a meditation on the fragility of consciousness itself. The clouds that envelope HR 8799e are not composed of water vapor or even the methane clouds we find on Jupiter, but rather a roiling mixture of silicates and metallic compounds, substances that form a perpetually shifting veil of microscopic rock and metal particles suspended in an atmosphere of hydrogen and helium, creating a visual landscape of rust-colored opacity interrupted by flashes of thermal radiation leaking from the planet's scorching interior. The temperature within these clouds fluctuates between approximately 1,000 and 1,400 Kelvin, hot enough to melt lead, yet still cool enough for certain compounds to condense into solid particles, resulting in a constantly evolving weather system where the very building blocks of the clouds themselves are in a state of perpetual transformation, condensing and evaporating in cycles we can barely comprehend from our comfortable terrestrial vantage point. The psychological mechanism that makes such a world terrifying to contemplate as we attempt to sleep is rooted in the fundamental incompatibility between this alien environment and the conditions our brains have evolved to find comforting and safe. For our sleep cycles developed under the expectation of a stable planetary environment with predictable atmospheric conditions, a solid ground beneath us, and a sky that, while sometimes dangerous, follows patterns we can understand and anticipate. When we imagine ourselves somehow transported to such a world, our minds immediately confront the absolute absence of any refuge, any shelter, any possibility of adaptation, because the hostile conditions are not limited to a specific region or time of day, but rather constitute the entire nature of existence on that planet. And our consciousness struggles to process the reality that in such an environment there would be no escape, no moment of reprieve, no dawn that brings safety, rather than merely a different variety of danger. The toxic clouds of HR 8799E represent a kind of primordial chaos, a reminder that the universe is filled with worlds that are simply incompatible with human survival, not through any accident or geological misfortune, but through their very fundamental composition and nature, worlds that were never meant to harbor anything resembling consciousness or awareness, and yet we have found them nonetheless. Forced to confront the reality that most of the cosmos consists of such uninhabitable realms rather than the exceptions like our own world. Yet despite this knowledge, despite our complete scientific understanding that such worlds pose no actual threat to us, despite the reassuring fact that we are separated from HR 8799E by distances so vast that light itself requires more than a century to bridge the gap, we persist in contemplating these worlds with a sense of deep unease as sleep approaches, suggesting that our fear is not truly about any logical danger, but rather about the existential implications of such environments' existence, the troubling reality that the vast majority of the universe is fundamentally inimical to life, and that our small bubble of habitability, our comfortable world with its breathable atmosphere and temperate climate, is not the default state of existence, but rather an extraordinary anomaly. A fragile exception in a cosmos dominated by toxic clouds and crushing pressures and temperatures that would vapor. Deep within the outer reaches of our solar system orbits a planet so fundamentally different from all others that its very existence seems to violate some unspoken rule of celestial mechanics. And that planet is Uranus, which rotates not like the other planets with its axis relatively upright and perpendicular to the plane of its orbit, but instead tilts at an extreme angle of approximately 98 degrees. Meaning it essentially rolls around the sun on its side like a cosmic marble, spinning perpendicular to the direction it travels through space. This extraordinary axial tilt means that Uranus experiences seasons unlike any other world in our solar system, where the poles face the sun directly for decades at a time, creating a day that lasts 42 years of continuous darkness followed by another 42 years of continuous light, a cycle so extreme and prolonged that it challenges our fundamental understanding of what a planetary climate could possibly endure. The psychological disorientation comes not merely from contemplating this geometric impossibility, but from imagining the lived experience of such a world if it harbored any form of consciousness, where entire generations would know nothing but uninterrupted darkness or uninterrupted light, where the concept of a day and night cycle as we understand it becomes meaningless, and where the very rhythms that govern life on Earth would be utterly unrecognizable. Scientists believe this sideways rotation resulted from a collision with a massive protoplanetary body billions of years ago, a catastrophic impact that essentially knocked Uranus over like a spinning top struck at precisely the wrong angle. Yet what remains most unsettling is how we have normalized this cosmic violence. How we discuss it as a casual footnote in planetary science, rather than contemplating the sheer improbability and strangeness of a world so fundamentally broken from its intended orientation. We speak of it as though it were simply another interesting characteristic, rather than a planet that defies the very laws that govern everything else around it. And perhaps this normalization itself represents the deepest terror, the way we compress the incomprehensible into digestible facts that we file away in our minds and forget, allowing ourselves to ignore that somewhere in the darkness of space, a world spins impossibly sideways through the void, indifferent to our confusion and incomprehension. And yet each time we launch a probe or train a telescope toward that tilted world, we are forced to confront anew the reality that our solar system is not the orderly, predictable mechanism we once imagined, but rather a chaotic arena where ancient collisions have left their marks written across the very bodies that orbit our sun, reminders that randomness and catastrophe have shaped the cosmos as profoundly as any law of physics. In this light, Uranus becomes not merely a curiosity of planetary mechanics, but a humbling mirror reflecting back to us the fragility of cosmic order itself, a testament to how a single moment of violence can echo across billions of years, reshaping not just a world's rotation, but our entire conception of what the universe permits to exist. When we consider that this same violent process may have shaped countless worlds beyond our observation, in star systems we will never reach, we begin to understand that Uranus is not an anomaly, but rather a visible window into a universe far more dynamic and unpredictable than our brief existence allows us to fully comprehend. The ice giants beyond Neptune may harbor similar stories of cosmic violence, their current configurations perhaps the frozen aftermath of impacts we can only reconstruct through computer models and educated speculation, yet Uranus stands as our only confirmed witness to such catastrophe, a solitary testament to the universe's capacity to remake worlds through forces we're only beginning to understand. In the constellation Cancer, approximately 149 light-years from Earth, orbits a world that is actively dissolving into the void of space, a gaseous mini-Neptune designated GJ3470b that represents one of the cosmos's most visceral demonstrations of planetary impermanence and slow-motion destruction. This world, roughly 4 times the mass of Earth and nearly twice its radius, orbits its parent star with such extraordinary proximity that it completes one full revolution in just 3.3 days, positioning itself so close to stellar radiation that its upper atmosphere exists in a state of perpetual thermal crisis. Where temperatures climb to approximately 900 Kelvin and the gravitational hold of the planet simply cannot maintain its gaseous envelope against the relentless solar wind that batters it without cessation. What makes GJ3470b genuinely terrifying is not merely its proximity to its star or its elevated temperatures, but rather the observable reality that this world is losing its atmosphere at a measurable rate, with hydrogen and helium escaping in a vast expanding cloud that extends far beyond the planet's physical boundaries, creating a visible tail of atmospheric material that trails behind the world like a comet, composed entirely of a world's dying gaseous essence. The planet's escape velocity has been fundamentally overwhelmed by the energy input from its star, meaning that any atom or molecule in the upper atmosphere that reaches thermal velocities sufficient to break free simply departs into space, never to return, in a process known as atmospheric hydrodynamic escape that represents the slow-motion annihilation of an entire planetary atmosphere measured in quantities of gas lost per second. The psychological mechanism that makes this scenario particularly unsettling operates on multiple levels simultaneously. Firstly, there exists the recognition that destruction need not be instantaneous to be absolute, that a world can be unmade gradually across millions of years through processes that are mathematically inevitable and utterly indifferent to any conceivable outcome or meaning we might assign to planetary existence. Secondly, there emerges the understanding that proximity, which we typically associate with warmth and nurturing in human experience, becomes here a vector of annihilation, with the very star that presumably gave birth to this world now actively erasing it from cosmic existence through the simple expression of its fundamental physical nature. We have normalized the concept of stellar destruction and planetary death through our scientific frameworks, treating these processes as routine astrophysical phenomena worthy of study and observation. Yet the actual experience of contemplating a world in the process of evaporation, a place where the ground beneath a hypothetical observer would be hemorrhaging its atmosphere around them, remains a scenario sufficiently alien and sufficiently permanent that our rational acceptance of it as natural seems almost absurd when confronted directly with its implications. The tragedy intensifies when we consider that GJ3470b likely began its existence with a substantially thicker atmosphere, perhaps even sufficient to support liquid water or chemical complexity, only to have that potential systematically erased by the very proximity that initially may have seemed favorable for habitability. In this sense, the planet represents not merely a world dying, but a world being unmade from a state of greater possibility into an ever-thinning ghost of what it once possessed. The observation of GJ3470b thus transforms from mere astronomical curiosity into a meditation on loss itself. A reminder that in the cosmos, the most profound extinctions occur not through violent collision or catastrophic explosion, but through the patient, inexorable theft of the very substance that made a world what it was, atom by atom, across epochs of time that dwarf human comprehension. Consider the surface of Mercury, the closest planet to our Sun, where the fundamental conditions for stability as we understand it simply do not exist, where the very concept of a habitable range becomes almost laughable when confronted with the actual measurements that scientists have recorded over decades of observation. During the day, when Mercury's surface faces directly toward the Sun, temperatures climb to approximately 430 degrees Celsius, hot enough to melt lead, hot enough that any material we might consider durable would begin to lose its structural integrity and transform into something entirely different. Yet when night falls on Mercury, when that same surface rotates away from the solar radiation that has been bombarding it, temperatures plummet to negative 180 degrees Celsius, a swing of more than 600 degrees in either direction, the most extreme thermal oscillation of any planetary body in our solar system. The mechanism behind this catastrophic temperature variance lies in Mercury's unique orbital and rotational characteristics, specifically its extremely thin atmosphere, which is barely substantial enough to be called an atmosphere at all, consisting mostly of oxygen, sodium, and hydrogen in such sparse quantities that it cannot possibly retain or distribute heat across the planetary surface. Without an atmospheric blanket to trap warmth and circulate it around the globe, without the insulating properties that thicker atmospheres provide to other worlds, Mercury's surface becomes entirely subject to the direct and unfiltered radiation of the Sun on one side and the absolute cold of space on the other. The planet's slow rotation, taking 59 Earth days to complete a single rotation on its axis, means that each hemisphere must endure extended periods of either relentless heating or absolute freezing, with no rapid cycles to moderate the extremes. What makes this situation conceptually terrifying is not merely the numbers themselves, but the recognition that this is happening right now, continuously, on a planetary body that exists within our own solar system, that is part of the same cosmic neighborhood where we evolved and developed our understanding of physical law. We have known about Mercury's temperature swings for generations, yet we continue to live with this knowledge compartmentalized away from our daily consciousness, treating it as an interesting scientific footnote rather than a stark reminder of how hostile the universe truly is when conditions deviate even slightly from the narrow range that sustains terrestrial life. The extreme temperature fluctuations on Mercury persist as an unchanging reality, a feature of planetary physics that will continue for billions of years, indifferent to our observations or our emotional responses to them, existing as a fundamental expression of how energy and matter interact across vastly different environments. Yet this indifference itself becomes the lens through which we might better understand our own planetary fragility. Mercury's thermal chaos serves as a cautionary exhibit in the Museum of Possible Worlds, a demonstration of what occurs when the delicate balance of atmospheric composition and orbital mechanics shifts even marginally from the conditions that permit complexity and life to flourish. In this light, Earth's relatively stable atmosphere and moderate axial tilt become not the natural default state of planetary systems, but rather an extraordinary confluence of circumstances that has allowed our species the luxury of predictability, the gift of seasons that change gradually enough for life to adapt and flourish rather than merely endure the violence of thermal extremes. This perspective shift, viewing Mercury not as a distant curiosity, but as a mirror reflecting the fragility of our own existence, invites us to reconsider what we mean by habitability and to appreciate that Earth's capacity to sustain life is less inevitable and more improbably fortunate than our everyday experience might suggest. Deep within the frozen expanse of the outer solar system, on a world so distant that sunlight arrives as little more than a pale whisper across the void, lies a landscape of stunning and unsettling beauty that challenges our fundamental understanding of how planetary geology operates. Pluto, that small celestial body relegated to dwarf planet status in 2006, possesses vast expanses of nitrogen ice that form glaciers comparable in their scale and dynamism to the great ice sheets of Earth, yet operating under conditions so alien and extreme that they seem to belong to a realm of impossible physics rather than our own universe. These nitrogen glaciers, concentrated primarily in the massive Tombo Regio, a heart-shaped depression on Pluto's surface, flow and shift with a slow, grinding inevitability across terrain that experiences temperatures plummeting to negative 370 degrees Fahrenheit, cold enough to transform nitrogen itself into a solid material capable of behaving like ice, creating vast plains of frozen nitrogen that extend for hundreds of miles across the dwarf planet's barren surface. The psychological unease these glaciers provoke stems from their fundamental wrongness when measured against our terrestrial experience, for we understand glaciers as ancient, slowly moving rivers of frozen water shaped by gravitational forces over millennia. Yet here on Pluto, we encounter something that operates by entirely different rules, where nitrogen instead of water comprises the glacial material. Where temperatures are so profoundly cold that the very chemistry of matter transforms into states we rarely encounter, and where the mechanisms of flow and movement remain partially mysterious despite our best scientific understanding. The Sputnik Planitia, the largest plain of nitrogen ice, demonstrates a convective process where warmer nitrogen from beneath rises upward while colder material sinks downward, creating a cellular pattern visible from space that appears almost organic, almost alive in its movement. Yet it is merely the expression of thermodynamic principles operating in an environment so extreme that it transcends the boundaries of what we consider possible on a planetary scale. What makes these nitrogen glaciers particularly disturbing is not merely their alien composition or their incomprehensible temperature, but rather the realization that we have normalized such strangeness, that we accept without excessive wonder that a world exists where nitrogen flows like water, where mountains of frozen methane rise against a black sky, where ice mountains collide and create scarps towering thousands of feet high. And that we continue with our lives unbothered by this cosmic impossibility suspended at the edge of our solar system, as though a world where nitrogen moves like water represents merely another catalog entry in the inventory of planetary phenomena rather than a profound challenge to our intuitive sense of how reality should function. Yet perhaps this habituation to the extraordinary reveals something essential about consciousness itself. Our capacity to expand the boundaries of the imaginable, to stand mentally upon that distant frozen shore and comprehend nitrogen flowing like water, methane mountains piercing a starless sky, and in doing so, to recognize that reality operates on scales and under conditions far more diverse and strange than our evolutionary history prepared us to expect, and that this very act of comprehension, however incomplete, represents one of humanity's most remarkable achievements. The New Horizons spacecraft, passing within 7,000 miles of Pluto in 2015, revealed that these nitrogen glaciers possess surface features, ridges, troughs, and flow patterns that bear striking resemblance to terrestrial glacial systems, suggesting that the fundamental physics of ice flow transcends the specific composition of the ice itself. A discovery that simultaneously grounds the alien in the familiar, while deepening our appreciation for the elegant universality of natural law operating across the cosmos. In the constellation Phoenix, approximately 190 light-years from Earth, orbits a celestial body designated WASP-43b, a world so utterly alien in its nature that it challenges the very foundations of what we consider habitable existence. This is a hot Jupiter, a gas giant that circles its parent star so closely that it completes one entire orbit in just over 19 hours, locked in what astronomers call a synchronous or tidally locked state, meaning the same hemisphere perpetually faces the star while the opposite side dwells in absolute, unrelenting darkness. The day side of WASP-43b experiences temperatures exceeding 1200 degrees Celsius, hot enough to vaporize most conventional metals, while the night side plummets to temperatures below -200 degrees Celsius in the perpetual shadow. This temperature gradient is so extreme that it creates the most violent atmospheric circulation patterns known in the exoplanet realm, with supersonic winds estimated to travel at speeds exceeding 2 kilometers per second, tearing across the terminator zone in a desperate attempt to distribute heat from the burning day side to the frozen night side in a futile and eternal cycle. The psychological mechanism that makes WASP-43 be particularly terrifying to contemplate rests not merely in the extremity of its conditions, but in the absolute permanence of its duality. Unlike Earth, where rotation brings the promise of daylight or the relief of nightfall, WASP-43b offers no such mercy or rhythm. If a being were somehow to exist on that world, it would never experience the fundamental temporal cycle that all life on Earth has evolved to depend upon. The notion of being forever trapped on a world where half the surface exists in a hell of molten temperatures, while the other half endures a frozen abyss, creates a conceptual trap for the human imagination. A scenario where neither flight toward the light nor retreat into darkness offers any salvation, only different forms of destruction. What persists despite the logical impossibility of life is humanity's continued fascination with such worlds as if they might somehow harbor secrets or contain the answer to profound questions about existence itself, as if suffering on an incomprehensible scale might yield some cosmic truth. Yet this obsession may reveal more about ourselves than about WASP-43b. We are creatures who have always sought meaning in the most inhospitable places, projecting our own struggles onto distant worlds as if to understand, through their extremes, the fragile balance that permits our own existence on this temperate sphere. Perhaps it is in this very act of contemplation, standing on our stable, rotating world and imagining the nightmare of WASP-43b, that we affirm our gratitude for the cosmic accident that placed us in the habitable zone, where darkness and light take turns in their eternal dance, and where the promise of dawn forever remains possible. In this way, WASP-43b becomes not a world to be understood, but a mirror held up to our own precarious existence, reminding us that the universe is indifferent to the conditions necessary for consciousness to emerge and flourish, and that our brief moments of awareness beneath an alternating sky are achievements of improbable fortune rather than inevitable outcomes. We look outward at WASP-43b and recognize in its sterile extremes the conditions we have unconsciously fled since our species first gazed upward at the stars. The recognition that most of the universe is fundamentally hostile to the delicate chemistry of thought itself, and that we survive not through cosmic design, but through an alignment of circumstances so particular that it borders on the miraculous. Yet even as we contemplate such worlds with a mixture of awe and dread, we might ask ourselves whether our fascination with WASP-43b's extremes reveals a deeper truth. That in seeking to understand the most hostile environments the cosmos offers, we are ultimately learning the grammar of a universe in which habitability is not the rule but the rarest of exceptions, and in that rarity lies both our prof. Kepler-442b orbits within the habitable zone of an orange dwarf star approximately 1,200 light-years from Earth. Yet what makes this world uniquely unsettling is not its distance, but the quality of light that bathes its surface in perpetual dimness. A condition that emerges from the fundamental properties of its stellar primary and the gravitational mechanics that have locked the planet into a synchronous rotation where one hemisphere faces eternal day, while the other endures endless night, with the terminator line between them creating a twilight band that represents the only region where temperatures might theoretically support liquid water and biological processes. Yet this twilight realm is not a gentle transition, but rather a violent zone of perpetual storms where the temperature gradient between the searing daylight side and the frozen darkness beyond generates atmospheric circulation patterns of extraordinary ferocity, winds that never cease, precipitation systems that never break, and a quality of illumination so dim and diffuse that any organism evolved to perceive its environment would experience a form of sensory deprivation even while bathed in starlight. The psychological mechanism that renders this scenario particularly disturbing operates through the human perception of twilight as a transitory state, a moment of passage between recognizable conditions of day and night. Yet on Kepler-442b, this transition is not transitory but permanent, eternal, unchanging across millennia and millions of years, which creates a conceptual vertigo when contemplated because the human circadian system evolved under the reliable rhythm of day and night cycling, and the idea of consciousness emerging in a context where this fundamental oscillation is replaced by static liminality contradicts our deepest biological expectations for how time and perception should operate. Despite the logical understanding that many exoplanets must exhibit such synchronous rotation, despite our knowledge that tide locking is inevitable for worlds near their stars, despite the mathematical certainty that such conditions exist throughout the universe in vast abundance, we continue to experience an intuitive revulsion toward the scenario, a persistent sense that something is fundamentally wrong with a world where sunset never comes, where twilight never deepens into restful darkness, where the sun remains perpetually at the horizon in an astronomical mockery of genuine day or genuine night, And this revulsion persists not because it is irrational, but because it reflects our embodied understanding that consciousness requires rhythm, that awareness requires transitions, and that a mind trapped in unchanging dimness, regardless of the objective temperatures or chemical compositions or theoretical habitability metrics, would experience a form of existential dissonance that no amount of scientific rationalization can adequately dissolve. You might imagine colonists establishing habitats within that twilight band, constructing artificial day-night cycles within sealed structures to preserve their sanity. Yet the knowledge that outside their walls the sun hangs motionless at the horizon, indifferent to their desperate performance of normalcy, would exert a psychological weight that no technological buffer could entirely ameliorate, a constant reminder that they inhabit a world fundamentally hostile to the rhythms upon which their consciousness depends. And perhaps this is the true horror that Kepler-442b presents. Not that it is uninhabitable, but that it is inhabitable enough to tempt us, to suggest that survival is possible, that life might cling to existence in that perpetual gloaming, yet survival in such conditions would exact a price in psychological coherence that no species, human or otherwise, could pay without fundamental transformation of what consciousness itself means. Such transformation might ultimately prove indistinguishable from extinction. The colonists who emerged from those sealed habitats after generations would be something other than human, their neurology rewired to accept the unacceptable, their sin. Consider the landscape of Mars, a world that appears deceptively still and unchanging when observed from Earth through our telescopes, yet harbors within its thin atmosphere one of the most violent and persistent meteorological phenomena in our solar system. Mars dust storms represent a category of weather event so severe and so capable of obscuring an entire planetary surface that they have fundamentally challenged our understanding of atmospheric dynamics on worlds different from our own. These storms emerge from the Martian surface with alarming regularity, particularly during certain seasons when the planet's axial tilt causes regions to experience extreme temperature variations, and what begins as localized disturbances across a canyon system or vast plain can rapidly escalate into planet-encircling tempests that rage for months without cessation. The dust particles themselves, far finer than anything we experience in Earth's most severe sandstorms, contain peroxide compounds and abrasive minerals that would devastate exposed equipment and human skin alike, suspended in an atmosphere so thin that the winds, despite traveling at tremendous speeds, carry less kinetic force than Earth's hurricanes, yet somehow manage to lift and transport these particles across thousands of kilometers with extraordinary efficiency. The psychological mechanism that renders Mars dust storms particularly unsettling exists in the contradiction they present. A world that appears barren and lifeless suddenly transforms into an entirely hostile environment where visibility drops to nothing and the sun itself becomes merely a diffuse glow behind an opaque veil of rust-colored particles, creating a sensation of being trapped within an endless cloud where direction and location become meaningless concepts. What troubles us most profoundly is how these storms persist as an intrinsic feature of Martian, whether despite the planet's apparently minimal atmospheric pressure, defying our intuitive understanding that such a thin medium should be incapable of generating such destructive forces. Yet year after year they continue, utterly indifferent to our expectations of what planetary meteorology should accomplish. A reminder that even worlds we consider well-understood harbor mechanisms of violence and obscuration that operate according to principles we have not fully comprehended. The 2018 dust storm that enveloped Mars for months dimmed solar panels on the Opportunity rover sufficiently to silence its communications, demonstrating how these phenomena pose not merely theoretical challenges to our understanding but tangible threats to our attempts at planetary exploration. In studying these storms, we are forced to confront the humbling reality that even our most sophisticated instruments and models remain inadequate to predict their onset or fully explain the thermodynamic processes that sustain them across such hostile terrain. Yet perhaps this inadequacy itself offers a peculiar gift. It ensures that Mars, despite our decades of robotic exploration, retains mysteries that demand our continued attention and humility, compelling us to return again and again to this rusty world not as conquerors of its secrets, but as perpetual students of its fundamental nature. The rovers we send to Mars must be designed with the assumption that they will eventually be buried or blinded by dust, their solar panels rendered useless, their cameras obscured, a humbling constraint that forces engineers to build redundancy and resilience into every system, acknowledging that on Mars, the environment itself is an adversary that cannot be negotiated with or overcome, only endured and adapted to. This acceptance of environmental limitation has paradoxically made us more capable explorers. The Perseverance rover, designed with lessons learned from Opportunity's entombment, carries radioisotope heater units that function independently of sunlight, ensuring that even when dust storms reduce solar input to near zero, the rover's essential systems continue their quiet work of observation and measurement, a testament to how our failures on Mars ultimately teach you. Triton, the largest moon of Neptune, presents one of the most peculiar orbital anomalies in our solar system, a celestial body locked in a retrograde orbit that defies the conventional patterns we observe throughout planetary formation and gravitational mechanics. Unlike the vast majority of moons that orbit their parent planets in the same direction as the planets rotate, Triton moves backward through space, traveling in a retrograde path that suggests it was not born as a natural satellite of Neptune, but rather was captured from the Kuiper belt eons ago, drawn into an increasingly inward spiral by gravitational forces that have been slowly but inexorably dragging this frozen world toward its inevitable doom. The physics of this situation creates a cascading set of circumstances that fundamentally distinguishes Triton from every other substantial moon in the solar system, as the retrograde orbit means that tidal forces generated by Neptune's immense gravitational pull are constantly working to destabilize the moon's trajectory, stretching its internal structure and gradually siphoning away its orbital energy with each passing revolution around the ice giant. What makes this scenario particularly unnerving is the certainty of Triton's ultimate fate. The moon will eventually spiral so close to Neptune that it will cross the Roche limit, the gravitational boundary beyond which tidal forces become strong enough to overcome the moon's own structural integrity. And at that point, Triton will be torn apart by the sheer gravitational stress, fragmenting into countless pieces that will form a spectacular ring system around Neptune before gradually falling into the planet's atmosphere. This process is not hypothetical or distant speculation, but rather an astronomical inevitability that will occur within the next few billion years, transforming a world that has existed for potentially longer than our own planet into a scattered debris field. And yet we have named this moon, mapped its features, and categorized it among Neptune's stable satellites while knowing with absolute certainty that its existence is finite and its destruction is guaranteed. The psychological dissonance emerges from our tendency to categorize objects based on their current state rather than their ultimate trajectory, a cognitive pattern that allows us to think of Triton as a place or a thing deserving of study and documentation, even though it is fundamentally a temporary celestial body destined for dissolution and destruction by forces that have already begun their inexorable work upon it. We observe this same pattern across the cosmos, moons of Jupiter and Saturn that similarly spiral inward, stars that burn inexorably toward their deaths, even galaxies destined to collide, yet we preserve them in photographs and nomenclature as though permanence were their natural state, as though documentation could somehow arrest the relentless entropy that governs all celestial mechanics, when in truth we are simply naming the doomed. And perhaps this is why Triton's retrograde orbit carries such weight in our collective imagination. It is not merely a moon, but a visible reminder that we ourselves exist within similar systems of inevitable decline, that our own planet orbits a star that will one day exhaust its fuel, and that the act of observation itself becomes a form of witness to the temporary nature of all things, a quiet acknowledgement that naming the doomed may be the most honest form of astronomy we possess. In this way, Triton becomes not a failure of planetary mechanics, but a mirror held up to our own condition, a crystalline world of nitrogen ice and cryovolcanoes that teaches us that observation, documentation, and even love for the doomed celestial things around us may be the most authentic response we have to the universe's fundamental impermanence. And so we turn our telescopes toward Triton not in denial of its fate, but in full knowledge of it, a conscious choice to bear witness to the beautiful and temporary, to study the condemned with the same rigor and reverence we might afford to the eternal, finding in that act of attention. Beneath the frozen crust of Jupiter's moon Europa lies one of the most hostile electromagnetic environments in our solar system, a place where radiation doesn't merely exist as background radiation, but as an active, relentless force that strips away molecules, ionizes atoms, and transforms any organic material into something fundamentally altered and unrecognizable. The surface of Europa receives approximately 540 rads of radiation annually, a dosage so extreme that it would deliver a lethal dose to an unprotected human in mere hours. Yet this terrifying reality exists in near-complete silence and invisibility, detectable only through instruments and scientific measurement. Jupiter's magnetosphere, one of the most powerful magnetic fields in the solar system, funnels solar wind and cosmic radiation toward its moons, and Europa, positioned within this maelstrom, exists in a constant state of bombardment by high-energy particles, primarily electrons and ions that strike the surface with such velocity and force that they fundamentally alter the chemical composition of whatever lies exposed. The radiation doesn't announce itself or provide warning. It simply arrives in waves, penetrating the thin atmosphere and barren landscape, transforming ice into new chemical compounds, breaking molecular bonds, and creating an environment where nothing familiar could possibly survive or persist unchanged. What makes this particularly unsettling from a psychological perspective is that the danger presented by Europa's radiation environment operates entirely outside human sensory perception, existing as a genuine threat that our bodies cannot detect, see, hear, or feel until the damage has already been done. And this fundamental disconnection between the reality of extreme hazard and our inability to perceive it directly creates a profound cognitive dissonance. We have normalized the existence of radiation as something distant and manageable on Earth, carefully controlled and contained within protective structures. Yet on Europa, it is the default state of existence, the baseline condition that defines what it means to exist on that world. The ice beneath the surface may shield any potential subsurface ocean from the worst of the radiation, yet the surface itself remains a place of constant atomic destruction, where the very ground beneath any potential explorer would be slowly and inexorably transformed by forces beyond control or containment. And this persistent threat continues to exist in the universe regardless of whether humanity ever witnesses it directly or acknowledges its reality. The salts that coat Europa's surface, exposed to this relentless particle bombardment, undergo chemical transformations that create complex organic compounds. Paradoxically, the very radiation that would sterilize any biological material may also be synthesizing the chemical building blocks that could sustain life in the sheltered ocean below, suggesting that Europa's most lethal feature and its greatest promise for habitability are inextricably linked. This paradox that destruction and creation operate simultaneously on the same irradiated surface encapsulates the fundamental mystery of Europa itself, a world where the conditions most hostile to life, as we understand it, may be precisely the conditions that make microbial existence possible in the depths below, transforming our intuitive understanding of habitability into something far more complex and counterintuitive than terrestrial experience could ever prepare us to comprehend. The radiation that scours Europa's surface also creates oxidants, oxygen-rich compounds that could fuel chemosynthetic metabolisms in subsurface hydrothermal vents, meaning that Jupiter's magnetosphere, through its violence, may be inadvertently provisioning the very chemical energy systems upon which alien life depends, transforming radiation from a barrier into an invisible lifeline stretching from the hostile surface down into the hidden ocean below.